हाँ जी.
सर अनअकैडमी नीट राइट?
हाँ हाँ, यस यस.
अच्छा रुको एक सेकंड.
स्ट्रीम मैंने स्टार्ट किया हूँ. Guys, can you all hear me? Am I audible, visible to everyone quickly in the chats? Quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to everyone. So, welcome back to one more amazing session from the team Unacademy NEET English. So, dear students, there was a technical glitch of for 5 minutes. I'm really sorry for that. I was not able to start the streaming, right? So I had to call the team and now it's all fine, I believe. Okay. So quickly give me some green signal, give me some fire symbol from the chats, right? So that we can start the session directly without wasting a lot of a time. Perfectly. Let me give you the context of this particular session. This is going to be super important session for all the NEET 2023 aspirants. First of all, why is that? Because in this particular session, we are going to exactly do top 30 most repeated concepts, which includes theory, tricks and PYQs. So I'll be doing, me and HSP Sir will be doing 10 important concepts from the chemistry, followed by your physics, followed by your biology. So 10 concepts from each subject, but these are the concepts from where for sure you are going to get the questions in your upcoming NEET examinations. You can mark my words, right? So in total 30 concepts. From 30 concepts, you will be getting almost 40 to 45 questions of same type, right, in your upcoming NEET examination. Are you ready for it? So people are asking about the duration of the session. The duration of the session is going to be maximum 3 hours. Maximum 3 hours it will be. Okay. I want you guys to call up all your friends. Let everyone get benefited from this particular session. Quickly call up all your friends. Guys, the duration is just 3 hours. 1 hour for chemistry, 1 for physics and 1 for biology. Call up all your friends and let's have a killer session yet again on this Unacademy NEET English channel. Are you ready for that? I need some fire symbols in the chats here, then only I'll be starting. You know it. I need some fire symbols first of all, then only I'll be starting. And I want the chat to continuously go up. It should not stop at all. Okay. So are you all ready for it? Ready for it quickly in the chats? Yes? Are you all ready for the session? So take out your pen and paper and let's have a killer session on the top 30 most repeated concepts of your physics, chemistry and biology. It's a combined session, maximum for 3 hours. Yeah? Perfect. Wonderful, guys. Love the josh which you guys are showing in the chats. All right, people. So let's get going then. Let's get started. The first concept which we are going to discuss is the concept of hybridization. I would say everywhere in the inorganic, in the organic, you use the term hybridization. And from this particular hybridization, a particular question is asked almost every year, right? And let me show you certain quick tricks by means of which you can calculate the hybridization. Okay. So this is all going to be our first concept. So understand, people, what exactly I'm going to say. Have a look properly. Okay. So the concept number 1, that is basically your hybridization. And from this particular hybridization, what all different types of questions are asked? Let's have a look on that. The first question which will be asked, that will be directly to check the hybridization. This is the first question asked, to check the hybridization. Second question is going to be, what is the geometry of the molecule? Geometry of the molecule predicted through hybridization. These are the two questions which are asked basically. Well, people, there is one simple method by means of which we can calculate the hybridization. And what is that particular method? That's what you call as the steric number method. That's what you call as steric number method. steric number method. With the help of this steric number method, you can easily check the hybridization in case of any molecule which you'll be given with. Okay. Now people, what this steric number method indicates, what is it all about? First of all, there's a term called as steric number. There's a term called as steric number. And how do we calculate the steric number? Steric number is calculated with the help of the number of sigma bonds plus the number of lone pairs. I'll show you exactly how to calculate the sigma bonds and lone pairs, right? You need to remember just few things, just few things. If the steric number comes out to be 2, the hybridization is simply going to be sp, and the geometry of the molecule predicted through hybridization, it's going to be linear. It is going to be linear. If the steric number of the molecule comes out to be 3, the hybridization involved is sp2 and the geometry is going to be trigonal planar. It's going to be trigonal planar. This is something which you need to remember. Similarly, if the steric number comes out to be 4, the hybridization involved is going to be sp3, the geometry involved is going to be tetrahedral. And in the similar way, if the steric number comes out to be 5, the hybridization involved is going to be sp3d, and the geometry predicted through hybridization is going to be trigonal bipyramidal. And similarly, dear students, if the steric number comes out to be 6, the hybridization involved is going to be sp3d2, and the geometry involved through hybridization, that's going to be octahedral. And at the end, if the steric number comes out to be 7, the hybridization is going to be sp3d3, and the geometry predicted through hybridization is going to be pentagonal bipyramidal. This is something which you need to know first of all. Okay. At the same time, dear students, remember one more thing. If they ask you in sp hybridization, or let's start with sp3d. If they ask you in sp3d hybridization, which d orbital is involved? Which d orbital is involved in sp3d hybridization? Do remember, it is dz square which is involved here. In sp3d2, it's going to be dx square minus y square and dz square. These are the d orbitals which are involved in case of your sp3d2 hybridization. And similarly, in case of sp3d3, which all d orbitals are involved here? One is going to be dz square, one is going to be dx square minus y square, and another one is going to be dxy. These are the 3 d orbitals which are involved here in sp3d3 hybridization. Okay. Now, dear students, let me show you exactly how to calculate the hybridization. Let's see exactly how, with the help of steric number, we can calculate the hybridization of different molecules. Okay. Let me take certain molecules first of all. Understand properly. For example, one very simple molecule I'm taking, that's NH3. Let's analyze NH3. Let's analyze water. Let's analyze XeF2. Let's analyze, for example, XeO2F2. These are certain molecules which we are going to analyze now. Okay. Dear students, have a look now. Understand properly what I'm going to say. In case of NH3, first of all, identify the central atom, which is your nitrogen here, right? If I ask you, how many valence electrons are there with nitrogen? Nitrogen, it's a group 15 element, so it has got 5 valence electrons, right? If I ask you, how many terminal atoms are attached with nitrogen? You will say there are 3 terminal atoms attached with nitrogen. Do remember, the number of terminal atoms is always equal to the number of sigma bonds. Number of terminal atoms is always equal to the number of sigma bonds, right? Now, dear students, nitrogen had 5 valence electrons, out of which it is utilizing 3. So, we are left with 2 electrons. That means there is 1 electron pair left on nitrogen as such. And that 1 electron pair you will be calling as lone pair. So, nitrogen has got 1 lone pair as well. Okay. And dear students, sigma bonds are 3, lone pair is 1. Calculate steric number. Steric number is sigma plus lone pair, right? 3 plus 1 comes out to be 4. And few minutes back I told you when the steric number is 4, that means hybridization is going to be sp3, right? And what is going to be the geometry predicted through hybridization? The geometry predicted through hybridization is going to be tetrahedral. It's going to be tetrahedral, right? Well, at the same time, if you ask me what is going to be the type of this molecule, if you ask me what is going to be the type of this molecule, see, nitrogen is the central atom. So let me represent central atom with A, right? How many sigma bonds? 3 sigma bonds. So it's going to be B3. How many lone pairs? 1 lone pair on nitrogen. The type of the molecule is going to be AB3L1. Very simple and basic, right? Have a look on the next one. Over here, oxygen is the central atom. If oxygen is the central atom, tell me how many valence electrons are there with oxygen? 6 valence electrons. You know it, right? Now, how many terminal atoms are there? 2 terminal atoms. Number of terminal atoms is equal to number of sigma bonds. If I ask you about the lone pairs, have a look. Out of 6, 2 have been utilized. Out of 6, 2 have been utilized. So 4 electrons will be left as such on oxygen in the form of 2 lone pairs, right? So there are 2 lone pairs. So sigma 2, lone pair 2. Steric number is going to be 2 plus 2, 4. The hybridization is going to be sp3, right? Hybridization is sp3. Simple. The geometry predicted through hybridization, what is it? The geometry predicted through hybridization is going to be tetrahedral. If you ask me about the type of the molecule, oxygen being the central atom, so it's A, 2 bond pairs, AB2, and lone pairs are 2. So AB2L2 is the type of the molecule, right? Simple. One more, XCF2, XCF2. If you talk about the xenon, xenon is a noble gas. And if xenon is a noble gas, how many valence electrons it has? It has 8. How many terminal atoms are there? 2 terminal atoms. And you know, the number of terminal atoms is equal to the number of sigma bonds. So 2 sigma bonds, right? So out of 8 valence electrons, 2 electrons are utilized to form 2 sigma bonds. So 6 electrons will be left as such on xenon in the form of 3 lone pairs. So there are 3 lone pairs basically, right? Now tell me in the chats, what about the steric number? Steric number is sigma plus lone pair, 3 plus 2, 5. Hybridization, sp3d. Which d orbital is involved? dz square. What about the geometry predicted through hybridization? Geometry predicted through hybridization is trigonal bipyramidal. As simple as that, right? Perfect. And the last one, XeO2F2. Now have a look on this one. Have a look on this one. If you talk about this particular molecule, let me draw its rough structure, a random structure, rough structure. This is, for example, xenon. There are 2 fluorine atoms. These are 2 fluorine atoms. There are 2 oxygen atoms as well. But you know oxygen is a divalent molecule, right? So it has to be double bond O, like this. It's a rough structure which I'm drawing. Now tell me, if I talk about this xenon, which is the central atom, how many valence electrons it has? It has 8 valence electrons. How many terminal atoms do you see? 2 plus 2, 4. Terminal atoms gives you the number of sigma bonds. So 4 sigma bonds. Now people, you tell me, out of 8 valence electrons, how many are utilized? Have a look. 1, 2, 3, 4, 5, 6. So out of 8 valence electrons, 6 valence electrons xenon has utilized. So it will be left with 2 electrons in the form of a lone pair. So there is 1 lone pair on xenon. Now calculate the steric number. Steric number is 4 plus 1, 5. Hybridization is simply going to be sp3d and rest, you know, done and dusted, right? So this was the first concept which is asked frequently in your NEET examination. Give me some thumbs ups in the chats if you mastered this particular concept. Quickly. Quickly guys, quickly everyone. Give me some thumbs ups in the chats. Quickly everyone. Quickly everyone. Perfect. Quickly, quickly, quickly. Everyone has to be involved in the chats. Then only it's going to be a fun session. Otherwise, you know, the rest. Yeah? Perfectly done, guys. Perfectly done. Let's have a look. Let's have a look on one more. Let's have a look on one more. All right. One question which was asked in your NEET 2022 from the same concept. Can you let me know its answer quickly? Which of the following will have maximum lone pair repulsions? Where do you see maximum lone pair repulsions? Quickly. You are going to answer this. First of all, identify your central atom. Calculate the total number of lone pairs. Wherever you find the maximum lone pairs, there only repulsions will be maximum. Right? Evident. Yeah? Done and dusted? Done and dusted, yes? So, isn't it going to be HCF2? Wonderful, guys. Perfect. So, moving on to our second concept. MOT, molecular orbital theory. From the molecular orbital theory, what kind of question do we get? From the MOT, if I talk about the concept number 2, from the MOT, we get questions based on bond order. We get questions based on bond strength. We get questions on bond dissociation energy. And we get questions based on bond length. These are the different set of questions which can be asked, right? And in the similar way, they ask certain questions like, calculate the total number of bonding electrons. Calculate the total number of bonding electrons. Calculate the total number of anti-bonding electrons. These are the concepts which are asked from the molecular orbital theory particularly. Okay? And how do we do all this? Someone is asking about hybridization of I3 negative. It's sp3d. Okay? I3 negative, ICl2 negative, it's sp3d. Perfect? Now, let's talk about all these things in detail. Okay? How do we calculate bond order? How do we calculate bond strength? How do we compare bond dissociation energy, bond length, bonding electrons, anti-bonding electrons? We need to see it. Okay? First of all, I would want you guys to remember one formula to calculate bond order. Bond order is always equal to half of number of electrons present in bonding molecular orbitals minus number of electrons present in anti-bonding molecular orbitals. Now, the point is, how do you calculate number of electrons in bonding and number of electrons in anti-bonding? That's something which I'm going to tell you in some time. But before that, remember, if the bond order comes out to be less or equal to 0, we say the species is non-viable. The species does not exist. This is one more question which is asked. Which of the following species does not exist? You need to calculate the bond order. If the bond order comes out to be 1, that means there is a single bond present between two atoms. If the bond order comes out to be 2, that means there is a double bond present. And you know, if the bond order is 3, that means there is a triple bond present. Okay? At the same time, one more simple thing which I would want you to remember. Bond order is directly proportional to bond strength, which is directly proportional to bond dissociation energy, which is inversely proportional to the bond length. This is something which I want all of you to remember at this particular point only. Question will come for sure from this particular concept. Yes? So first of all, I'll show you the general procedure to do all this. Then I'll give you one simple trick as well. Okay? Have a look. People. Have a look. One thing which I would want you guys to remember. This is something which I want you guys to remember. The way you write the electronic configuration, in the similar way you guys are going to write the molecular orbital configuration. And this is the order which you guys will be following to write the molecular orbital configuration for the species which contains electron up to 14. Sigma 1s2 should be filled first. Sigma star 1s after that. Sigma 2s after that. Sigma star 2s after that. Then pi 2px, pi 2py should be filled. Then your sigma 2p z should be filled. Then pi star 2px, pi star 2py, sigma star 2pz. So first of all, do remember this particular order. This is the electron filling order in case of molecular orbitals. Now how exactly? you guys are going to do it? How exactly you guys are going to do it? Have a proper look. See, first of all, every orbital can accommodate maximum of 2 electrons. That's something every one of you will be knowing. Yes? Every orbital accommodates maximum of 2 electrons. Okay? Now have a look. We are starting with H2 molecule. In case of hydrogen, if I talk about hydrogen in particular, hydrogen, atomic number 1, it has got 1 electron. It has got 1 electron because its atomic number is 1. In case of H2, how many electrons in total? There will be 2 electrons in total. He2, one helium atom contains 2 electrons. So 2 helium atoms will contain 4 electrons. This will contain total 6 electrons. This will contain total 8 electrons, right? Now, after calculating the total number of electrons, what you need to do is, you need to fill these electrons in these molecular orbitals. Have a look. H2, total how many electrons? 2 electrons. So put those 2 electrons here. So its molecular orbital configuration is just going to be sigma 1s2, right? Sigma 1s2. All the star ones, this is star, here this is star, these are called as anti-bonding molecular orbitals. Without star means bonding molecular orbitals, right? Star ones means anti-bonding molecular orbitals. Without star means bonding molecular orbitals, right? Since you wrote the molecular orbital configuration, now calculate the bond order is equal to half of number of electrons in bonding, 2 electrons in bonding, minus number of electrons in anti-bonding, 0. So 2 divided by 2 comes out to be 1. So bond order in case of H2 is 1. Simple. Which you already know. H2 exists in this form. H single bond H. Correct? Talk about He2. Total 4 electrons. So fill these 4 electrons. 2 here and 2 here. So its molecular orbital configuration is going to be sigma 1s2, then sigma star 1s2. Perfect. 2 in bonding, 2 in anti-bonding. Now calculate the bond order, which is going to be equal to half of number of electrons in bonding, that's 2, minus number of electrons in anti-bonding, that's 2. Value comes out to be 0. And you know, if the bond order comes out to be 0, the molecule does not exist at all. Correct? Similarly, you can check all these ones. Chalo, let me show you one more. 6 electrons. 6 electrons in case of Li2. 2 here, 2 to 4, 4 to 6, right? Now calculate the bond order. Bond order is going to be equal to half of. Calculate the number of electrons in bonding, 2 and 4, minus anti-bonding, 2. 4 minus 2 comes out to be 2, 2 by 2 is 1. So bond order comes out to be 1. That's all, right? One special case, that is C2. In case of C2, what you will find? You will find the bond order as 2. In case of C2 molecule, when you calculate the bond order will come out to be 2. That means this is the molecule. And there is one special thing in C2, that both these bonds in case of C2 are the pi bonds. Both these bonds in case of C2 are the pi bonds. Do remember this particular thing as well, right? So I'm sure from now onwards, if they ask you about the bond order calculation, you can easily do that, right? You can easily do that. I'm sure it's clear to everyone. Similarly, my dear students, these are the other examples which you can try afterwards, okay? And do remember one more thing. That's very important. When you check N2 positive and N2 negative, their bond order will be 2.5. Both the ones will have bond order same. Both the species will have same bond order. Now, how can you compare which one is more stable? We know bond order is directly proportional to what? Is directly proportional to stability. Correct? If both the ones have same bond order, how do you compare the stability? Now, those species which have same bond order, in order to compare the stability, just do one thing. Calculate the total number of antibonding electrons. More the antibonding electrons, lesser is going to be the stability. And you already know how to calculate the antibonding electrons. Write the molecular orbital configuration, calculate the antibonding electrons. More the antibonding electrons, lesser the stability. That's all. Right? So tell me, among these two, which one will be more stable? N2 positive will be more stable. Why? Because N2 positive has got lesser antibonding electrons as that of N2 negative. Is that clear to everyone? Let me know quickly in the chats. And if you just want to remember the trick which I gave you in the yesterday's short as well. All the 14 electron species will have bond order 3, 15 electron species will have bond order 2.5, 16 electron species will have bond order 2, 17 electron species will have bond order 1.5, all the 18 electron species will have bond order 1, 13 electron species bond order 2.5, 12 electron species 2, 11 electron species 1.5, and 10 electron species will have bond order of 1. You can remember it like this as well, no issues. One more thing, whenever you talk about isoelectronic species basically are the ones which have got same number of electrons. For example, if I talk about N2, if I talk about CO, N2 contains 14 electrons in total, CO contains 14 electrons in total. So these two are basically your isoelectronic species, and isoelectronic species always have same bond order. Do remember this particular point as well. Is it clear to everyone? Quickly guys. Quickly, let me know in the chats, everyone. Yes, perfect. And at the same time, if the species contains more than 14 electrons, then this is the order which you have to follow. One example I'll show, rest it's simple. For example, you have got O2 molecule. One oxygen contains 8 electrons. So 2 oxygens will contain total 16 electrons. So fill 2 here, 4, 4 to 6, 6 to 8, 8 to 10. Now these are degenerate. 10, 11, 12, 13, 14. Again degenerate. 15, 16. So write the configuration. It's going to be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1, right? So if I want to calculate the bond order through the trick, you can easily calculate. Now if you want the actual procedure, half of number of electrons in bonding, 2, 4, 6, 8, 10. 10 electrons in bonding minus anti-bonding, 2, 4, 5 and 6. 6 in anti-bonding, 10 minus 6 is 4, 4 by 2 is 2. Perfect. One more thing they can ask you. They can ask whether this particular species is paramagnetic or diamagnetic. How you exactly are going to check it? Paramagnetic or diamagnetic? Look at all these molecular orbitals. This is filled, this is completely filled, this is filled, these two are filled, this is not filled, this is not completely filled, right? These two molecular orbitals are containing unpaired electrons. Wherever you see the unpaired electrons, the species is going to be paramagnetic. Wherever you see the unpaired electrons, the species is going to be paramagnetic. Wherever there are zero unpaired electrons, wherever you see zero unpaired electrons, that species is going to be diamagnetic. That's all. Perfect? Perfect. Wherever you see the unpaired electrons, species, directly you'll be taking as paramagnetic in nature. I'm sure this is clear to everyone, right? Perfect? Perfect, guys? So if this is clear, then what should be the answer of this question? What do you think? Quickly. Which of the following species have same bond order? You just have to see the species which are isoelectronic. Isoelectronic species always have same bond order, right? Quickly in the chats. Everyone in the chats. Quickly, yaar. And I can see more students are watching and less number of likes. That's not done. And I can see all the students have not subscribed to the channel. Yes? NEET 2017. Quickly. I want the correct answer. Everyone. Yes, now you guys are killing it. Absolutely, guys. See, if you talk about Cn negative, carbon has got 6 electrons, nitrogen has got 7 electrons, there is a negative charge, add that up, so total 14 electrons. In case of carbon monoxide, again 14 electrons. So they are isoelectronic, so their bond order is going to be same, and 14 electron species have got bond order 3. Okay? If you ask me whether these species are paramagnetic or diamagnetic, okay, if I ask you whether these species are para or dia, what do you think? Paramagnetic or diamagnetic? You write their molecular orbital configuration, there'll be no unpaired electron. If there is no unpaired electron, these are both the species are going to be diamagnetic. Simple, done and dusted, right? There is one more concept from which the question frequently comes. This is going to be the Nernst equation. Nernst equation. Have a look. Have a look, people. It's a very simple topic, right? And see what kind of questions are asked. First of all, how do we exactly write the Nernst equation? That is the point. The simplified version of the Nernst equation is like this. E cell is equal to E naught cell minus 2.303 RT divided by NF, and it's going to be log of QC. This is the generalized form of the Nernst equation. Generalized form of the Nernst equation. Now, dear students, if I keep temperature as 298 Kelvin, if I take the value of R as 8.314 joules per Kelvin per mole, if I take the value of Faraday's constant as 96500 coulombs, if I put all these terms into this equation, I'll be getting one more equation as E cell is equal to A naught cell minus 0.0591 divided by N, and it's going to be log of QC. This is the equation which you will be using in majority of the questions. In majority of the questions, I'm saying, right? In majority of the questions, you'll be using this equation. And from this particular equation, you can easily calculate EMF of the cell. EMF of the cell under non-standard conditions. They will be asking you calculate the EMF of the cell under non-standard conditions. This is going to be the equation which you'll be using. Okay, this is the equation which you'll be using. At the same time, my dear students, is this the only application of Nernst equation to calculate EMF? The answer is no. The answer is no. You can calculate oxidation and reduction potential of electrodes of half cells as well. This is particularly the Nernst equation for complete cell, for complete galvanic cells. Well, if you need to calculate the oxidation potential for a half cell, oxidation potential for a half cell, how exactly you are going to modify this? How exactly you are going to modify this equation? Have a look. Instead of E cell, you write EOX, oxidation potential, is equal to, instead of E naught cell, you write E naught OX, standard oxidation potential, minus 0.0591 divided by N, and it's going to be log of QC. This is the equation which you guys will be using in order to calculate the oxidation potential of the half cell, the oxidation potential of the electrode under non-standard conditions, right? And at the same time, people, if they ask you to calculate reduction potential of the same half cell, reduction potential is equal to standard reduction potential minus 0.0591 divided by N, and it's going to be log of QC. This is going to be the equation which you all will be using to calculate the reduction potential of the half cell, reduction potential of the electrode under non-standard conditions. Let me show you one or two questions, you'll master it properly. Have a look. Let me show you a few questions, you'll master it completely. And then it's going to be HSP Sir who is going to be with few more amazing tricks. Yeah? All right. For example, this is the question on your screen. Let's see how exactly we are going to solve it. Calculate the oxidation potential of the following half cell. This is the half cell that's given. This is the half cell that's given. The oxidation state of iron here is 0. Right here it's +2. This is something every one of you would know. What am I supposed to calculate? I'm supposed to calculate the oxidation potential. You know, oxidation happens at anode, right? So I'll make sure this particular electrode behaves like the anode. I'll make sure this particular electrode behaves like the anode. And at anode, oxidation takes place. Oxidation means loss of electrons. Here, iron is going into Fe di positive. And you know, when iron goes into Fe di positive, it loses electrons. If you ask me how many? I'll say 2. 0 to +2. 2 electrons lost. Now, people, if I ask you how many moles of electrons are exchanged here, you will say 2 moles of electrons are exchanged. So, N value is equal to 2. Number of moles of electrons exchanged is equal to 2. Correct? If you ask me, write the QC value, write the reaction quotient value. Reaction quotient expression We have to start from the product. This is an aqueous state. So I'll be taking its concentration. Concentration of Fe di positive raised power 1. This is in solid state. I've got nothing to do with this. Now tell me what is the concentration of Fe di positive? It's 0.1 molar. That means 10 raised power minus 1. Correct? QC calculated. N calculated. Right? What do we have to calculate finally? Oxidation potential. How will you calculate oxidation potential? Oxidation potential is equal to standard oxidation potential minus 0.0591 divided by N. Then it's going to be log of QC. As simple as that. This is something we need to calculate, right? Is equal to standard oxidation potential should be given. Look here, this is di positive, this is 0. So plus 2 to 0 means decrease in the oxidation state. Decrease in the oxidation state is something which you call as reduction. So this is basically the standard reduction potential. But what do I need? I need standard oxidation potential. So just reverse the sign. It is minus 0.44. So I'll be taking plus 0.44. Minus 0.0591. N value we know 2. And it's going to be log of QC is 10 raised power minus 1. That's it. Done and dusted. Right? Log of M raised power N. N log M. So minus 1 comes to the front. So minus 1 multiplied by log 10. Log 10 is 1. Just solve this particular thing. Get the answer in volts. That's it. Got it? Got it, people? Quickly, let me know in the chats. I can see everyone has not liked the session yet, yaar. Quickly. Quickly, everyone. Quickly. Calculate. So one question I showed you about the oxidation potential. Now let's have a look on one more question. That is calculate the reduction potential of this particular half cell. This is the half cell that's given. This is the half cell that's given. I need to calculate its reduction potential. You know reduction takes place at cathode, right? So I'll make sure that this electrode behaves like the cathode. I'll make sure the electrode behaves like the cathode. And you know, at cathode what happens? At cathode reduction takes place. Reduction means gain of electrons. This is a hydrogen electrode. And when hydrogen electrode behaves like the cathode, the reaction has to be 2 times H positive aqueous plus 2 electrons gives H2 gas. This is going to be the reaction first of all, right? Now tell me how many moles of electrons are exchanged. I would just say 2 moles of electrons are exchanged. That's it, right? Write the QC expression. Start with the product. It's in gaseous state. So partial pressure of H2 raised power 1 divided by concentration of H positive raised power 2. What is the partial pressure of H2? That's 10 atm. What is the concentration of H positive? 0.1 molar, but this is square, right? So it's going to be 10 divided by 10 raised power minus 2. The value comes out to be 10 raised power 3. This is QC. Done till here. This is QC. This is QC, right? If this is QC, now calculate the reduction potential. Use the Nernst equation. It's equal to E naught RED, standard reduction potential, minus 0.0591 divided by N, and then it's going to be log of QC. As simple as that. Now you must have heard till now, you must have heard that when we talk about the hydrogen electrode in particular, the standard SOP, the standard oxidation potential, as well as standard reduction potential of the hydrogen electrode, that's always 0, right? Now people, you check, all the things are given. E naught RED, standard reduction potential 0. N value, you calculated. QC value, you got. So from here, you can easily calculate the reduction potential of the half cell. Is that clear? Is that clear to you? Everyone in the chats with me? Quickly, and the ones who have not subscribed to the channel yet, please do subscribe to the channel right now. Right now means right now. Okay, perfect. So I showed you exactly how to calculate the oxidation potential and reduction potential under non-standard conditions. There can be one more type of question asked. Then we'll move on to the inorganic chemistry. Okay. One more type of question can be asked from here. And this year, expect at least 2 questions from Nernst equation. Last year, they asked 2 questions from Kohl-Ross law. They are not going to repeat the same this year. This year, expect minimum 2 questions from the Nernst equation. That's why I'm focusing more here. Okay, that's why I'm focusing more here. By the way, tomorrow at 8 p.m. sharp, at 8 p.m. in the night, me and HSP Sir, we are coming up with the most predicted NEET 2023 chemistry paper. Yesterday, me and HSP sir, we sat for almost 3 hours. We collected the questions, right? Out of all the experience which we have, he has the 25-year experience. I have, of course, less than that, but still something is there. Okay, so we collected almost some 50 questions, right, which we are going to discuss with you tomorrow in the most predicted NEET 2023 chemistry paper. So do join that particular session. That is going to be an amazing session. That's going to help you out a lot. Okay, tomorrow at 8 p.m. Okay, look at this one. Look at this one. Calculate the EMF of the cell. EMF unity calculate under non-standard conditions. First of all, since you have to calculate EMF, again you'll be using the Nernst equation. These two lines, they represent the salt bridge. On the left side, you'll be writing the anode. On left side, you'll be writing the anode. And you know, at anode oxidation takes place. Tin is getting converted into Sn di positive. So the reaction has to be Sn solid gives Sn di positive aqueous. With this, you'll be writing 2 electrons. This is the reaction taking place at anode because at anode oxidation takes place. Okay. Similarly, oxidation means loss of electrons, right? Similarly, at cathode, what happens? Reduction takes place. Pb di positive getting converted into Pb solid. So the reaction has to be Pb di positive aqueous plus 2 electrons. It gives Pb solid. This is the reaction taking place at cathode. Okay. Now just add these two reactions. After adding these two reactions, it's tin solid. Just remember the procedure, guys. Remember how I'm solving the equation. Adding these two reactions. It gives Sn di positive aqueous, and with this, you're writing Pb solid. This is going to be the reaction, the net reaction which we have. Okay, this is our net reaction. This is our net reaction. While adding the reactions, how many electrons got cancelled? 2. So I would say 2 moles of electrons are being exchanged in the net cell reaction. 2 moles of electrons are being exchanged in the net cell reaction. Okay, right? Now, people, we are left with one more thing. That's E naught cell. How do you calculate E naught cell? It's E naught of cathode minus E naught of anode. This is the standard reduction potential of cathode, and this is basically the standard reduction potential of anode. Now have a look. This is your anode. This is your cathode. Standard reduction potential of cathode. Standard reduction potential of lead electrode. That's minus 0.13. Minus standard reduction potential of anode. That's minus 0.14. The value comes out to be 0.01 volts. This is E naught cell. Since you calculated E naught cell, now it's going to be the Nernst equation. E cell is equal to E naught cell minus 0.0591 divided by N, and now it's going to be log of QC. One thing we forgot, that's to calculate QC. Calculate QC for the reaction quotient. Start with Sn di positive. It's in aqueous form, its concentration raised power 1 divided by concentration of Pb di positive raised power 1. What is Sn di positive concentration? 1 molar. What is Pb di positive concentration? 10 raised power minus 3. The value overall comes out to be 10 raised power 3. Okay. Now, E cell will be equal to E naught cell we calculate 0.01 minus 0.0591, N value is 2, and it's going to be log of QC, 10 raised power 3. 10 raised power 3, N log M. So 3 comes to the front, log 10 is 1. Now, it is just a matter of calculation. Solve it and get the answer in volt. Is it clear? Guys, this particular concept, okay? This particular concept, focus on this a lot, right? Now, I'm calling up HSP Sir. He'll be discussing few more concepts with you, okay? He'll be discussing few more concepts with you. Then we have got Physics Sir, your captain. He'll be joining after me. Mr. HSP Sir.
Hey! Thank you, sir. Thank you, sir. And thanks a lot. That much of appreciation.
People, all okay till here?
How's the Josh? I want to see the Josh. First of all, if I am perfectly audible and visible,
You're already, sir.
yes, I want the welcome with your thumbs up. I want to see that energy in the chat section. Wow, I can see the chat section is, yeah, it's colorful now. That's really fantastic. Yes, that's really fantastic. Awesome.
Perfect.
So
HSP
let's start.
Sir is going to continue with you now. He'll be discussing few more like top concepts.
Yes.
By the way, these are the concepts from which surely you are going to get the question.
Yes,
Surely,
yes.
like 100%. 100% means 100%.
Yes, inorganic. First, we are going to start with inorganic, right?
Sir will not take more than 40 minutes. Just be
Yes,
with me.
yes, yes. Thank
I'll
you,
take
thank
leave.
you.
Okay.
So, let's start. Here is the most important question. Just do let me know in the chat section. Can you see this question? Is it visible to all of you? Now, how to do it? Everyone, see which of the following statement is not correct. First of all, we have to focus at this point, not. Because reading of the question is really very important. Once if you are not focusing on the question, if you are not reading it properly, you won't be able to answer the question. Yeah, I can see your Josh. I can see your Josh. That's really awesome. So let me tell you each and everything about this boron. Once the concept is clear, Diborane. Diborane is B2H6. Now, first of all, we should know what is boron. Boron atomic number is 5, 1s2, 2s2 and 2p1. Is it clear? Boron's atomic number is clear. Hydrogen, helium, lithium, beryllium, boron. Boron's atomic number is 5. So, outermost is having 3 electrons. I can say 2s2 and 2p1. You can see very clearly in the ground state, it's like this. Now, when I provide some electron, energy will increase. If I provide some energy to the electron or to the atom, this one electron is going to shift over here. Now see what will be the position. It will look like this. So this is being excited state. Now if I talk about excited and hybridized state, excited and hybridized state, what will happen? These 3 will combine together. 1 from S and 2 of P will combine together. sp2 and 1 pure p orbital. Can you see? sp2, this is sp2, this is also sp2, this is also sp2. sp2 means if you are having 1 orange and 2 pineapples, and if you mix them, you will get juice. 1 glass, 1 glass, 1 glass, 3 glasses juice. Yes, 3 glasses having juice, 1 orange and 2 parts of pineapple means sp2, means 1 by 3 part of orange, 2 by 3 part of pineapple. Are you getting this point? Everyone getting this point? So sp2 hybridized. Now I will say boron is like this. Boron is like this, and better to say, let me take another page, let me draw over there. I will say boron will be like this, 1 sp2, another 1 sp2, 1 more sp2, all they are with 1 electron, all they are known as sp2, sp2, sp2. Now, 1 is being pure p orbital, which is not hybridized. So, this is vacant orbital. This is your vacant orbital, kids. This is not the hybridized one. So, when they are going to combine with hydrogen, see, if I combine it with hydrogen, now I will say boron is having total 6 electrons. Boron is having total 6 electrons. So could you please help me with whether boron is electron deficient or electron efficient? Right now only 6 electrons. Better to say only 6 electrons. So it is being electron deficient. Electron deficient. Now just to complete its octet, boron is saying, oh, I'm having only 6 electrons. I'm feeling hungry. I want to have 8 electrons in the valence shell. Now what boron will do just to complete its octet? Just do let me know in the chat section what boron can do. So right now I'm having BH3 and it will dimerize and it will become B2H6 and this is known as diborane. This is really very important, diborane. Here the hybridization is sp2 and there the hybridization is sp3. Now let me tell you why the hybridization got changed. It is here sp2 and there it is sp3. This is the most important thing and this is given in your NCERT. I am going to explain it each and everything. See to it. Everyone see to it. If I say this is one plane, let me take one plane. This is one plane. Just try to understand it. I have taken one plane so that I can show you the geometry also, because number of questions will come from the geometry also. Let me take boron. This is one boron. This is another one boron. 2 boron atoms I have taken. Now let me draw. This is being hydrogen. This hydrogen is coming towards observer side. This is coming towards your side. It is being in the plane only, and this hydrogen is going away from observer. Can you see? Same here. This hydrogen is coming towards observer side, means coming towards your side. And this hydrogen is going away from observer. Can you see? Now it was having one more hydrogen. Let me draw that hydrogen over here. This hydrogen, and it was also having one hydrogen. Can you see, everyone? When it was alone, it was BH3, sp2 hybridized with vacant orbital. But see what I am going to tell you. This was having one vacant orbital. See to it, this is the vacant, that vacant orbital, and this is also having one vacant orbital, right? But here, see, is it vacant or not? See to it, here it is going to be vacant or not. This is boron. This boron's electron, 1 electron, and this is hydrogen's electron. This electron is hydrogen's electron. How many electron? This electron belongs to boron and that electron belongs to hydrogen, and it is vacant. Let me draw its orbital. Its orbital is like this. Hydrogen's orbital is like this. Now at this point, can you see how many orbitals are present? At this point, 1 orbital, 2 orbital and 3rd orbital. Total 3 orbitals are present. 3 orbitals, but how many electrons? 3 orbitals, but only 2 electrons. Are you getting my point? Total 3 orbitals, but only 2 electrons. Total 3 orbitals, but only 2 electrons. But only 2 electrons. This is known as 3-centered 2 electron pair bond. What I am saying? 3-centered 2 electron pair bond, also known as banana bond. Why it is known as banana bond? See to it. Let me draw the structure. because of its shape. What I'm saying? Because of its shape, it looks like banana. See to it. Its shape is like banana. Can you see? Can you focus over here? Can you focus on this shape? This shape is like banana. It is going perpendicular to the plane. If this is the plane, if I talk about these 4 hydrogens, they are lying in the plane. 1 hydrogen, 2 hydrogen, 3 hydrogen and 4 hydrogen. How they are bonded? See to it. How they are actually bonded. This is 1 orbital. That is 1. This is 1. This is 1. These, I will say, definitely I would like to say 1 electron from boron and 1 electron from hydrogen, 2 centered 2 electron pair bond. We can also call these 4 as terminal bonds. 4 terminal bonds. Total 4 terminal bonds. They are lying in the plane. Whatever is the plane of boron, same is the plane of these 4 hydrogens. Are you getting? Everyone, are you able to understand? These 4 bonds, they are just lying in the plane of these 2 boron. But this is going perpendicular to the plane. Is it visible? And same is over here. It is also going downward side. It is also going downward side. See, it's like this. This is your hydrogen and this is the orbital. And if I draw the structure, this is going downward side, downward side. This is banana, this is banana, these 2 banana. Are you able to see? Is the picture very clear to all of you? See, this is going upward side, upside, and this is going downward side. And these are known as banana bonds. You can say banana bonds. You can say tau bond. Either way you can go. So total how many 3 centered 2 electron pair bond? We have got 2. We have got 2. These are 2. 3 centered 2 electron pair bond and we have got 4. Now in the NCERT even their bond lengths are given. In the NCERT even the bond lengths are given. So if the examiner is asking what is the bond length of this banana bond, which bond length is more? Which bond length is more? So remember that bond length, just let me tell you, which friendship is better? Could you please help me? Which friendship is better? There are 2 people. There are 2 people. Which friendship is better? Just let me know which friendship is better. Two people and 2 tiffins. Both they are bit different. This is first friendship. Now second type of friendship is 3 people, only 2 tiffins. Only 2 tiffins. This is the analogy which I am trying to give you, my dear kids, for the first one. 4 terminal bonds, 2 centered 2 electron pair bond, and this I am giving 3 centered 2 electron pair bond. Only electrons are 2, but 3 people, 3 orbitals are sharing 2 electron, 2 orbitals are sharing. Just do let me know in the chat section which one is better, A1 or B1. 2 people, 2 tiffins, 3 people, only 2 tiffins. Which one is better? Which one is long lasting? So definitely the first one is going to be long lasting. So this is better bond. better bonding, and better is the bonding, less will be bond length, less bond length, and it will be having more bond length, So remember that banana bond is a weaker bond, so bond length will be more. Banana bonds bond length will be more, and this is ACD-PM. This is the trick for bond length, ACD-PM. ACD means A for ABCD, A means 1, C means 3, D means 4, 134 picometer. And if I talk about terminal bond, AIPM, A means 1, another A means 1, and I means 9. So this is all about Diborane. Once if this much is clear, the trick is clear, do let me know in the chat section. Then I am going towards the question. Do let me know in the chat section this trick. ACDPM, A1C34 ABCD, and this is AAI. This is given in NCERT. If the trick is clear to all of you, if you like the trick, just do let me know. So let's move towards the question. So this was your question. I hope you have not seen the answer. Just do let me know what's the answer. What's the answer? Everyone, just do let me know in the chat section what's the answer. Which is not correct about Diborane? There are two 3-centered 2-electron pair bond. That means they are talking about there are two banana bonds. This is true. This statement is true. Absolutely true. There are 4 terminal BH, the 2-centered 2. This is also true. The 4 terminal hydrogen atoms and 2 boron atoms, they are lying in the plane. This is also true. Both the boron atoms are sp2. No. The hybridization got changed. So this is false. And this is your answer. So definitely this is your answer. Another question. Concept from DNF block. If you're ready, let's move. The spin only magnetic moment of nickel 2+. How to do it? See, nickel, we know that nickel's atomic number is 28. So 28 we can write like this, 82. Always do write like this. 28 you can write like this, 82. Reverse it, 3d8 4s2. This much is clear. 3d8 4s2. Now nickel 2+. Nickel 2+ means 2 electrons eliminated out. So what will you get? You will get 3d8 4s0. Okay. Now the spin only magnetic moment of nickel 2+ in aqueous solution. That means water. Water is what? Weak field ligand. Water is what? Weak field ligand. WFL. Now how to write 3d8? 1, 2, 3, 4, 5, 6, 7, 8. How many unpaired electrons? Kids, how many unpaired electrons? 2 unpaired electrons. So I'm not going to deal with the formula that Bohr magneton is equal to square root of n into n plus 2 Bohr magneton. Just I can write the answer. See, whenever the number of electrons are 2, then answer will be 2 point something. So 2.84. This is going to be the answer. Are you getting my point? Suppose if you are having 5 unpaired electrons, 5 point something, 5.92. Suppose you are having 4 unpaired electron, 4 point something, 4.90. If you are having 3 unpaired electrons, 3 point something, 3.87. Are you getting my point? So do remember this trick. Whatever the number of unpaired electrons are there, the value of Bohr magneton will be something more than that, 2 point something. So this something, so let's see, this is the answer. Is it clear? This is the answer. Okay, now see another question. Generally, the transition elements from colored salt due to the presence of unpaired electron, which of the following compound will be colored in solid state? This is the most frequently asked question. Just to remember CuF2. Another question. Gadolinium belongs to 4F series. Oh, lanthanoid. Gadolinium is being lanthanoid. Now kids, once the d orbital is filled, that means d2 configuration, then we have to fill 4f. But remember that how many gods are there? What do you think? How many god? God is one. This is the exceptional configuration. God is one. This is the exceptional configuration. Gadolinium does not follow IUPAC standard rules. God is one. So this is the exceptional configuration, and the trick for it is God is one. You like the trick? God is one. So where is God? God is one. D1. 5D1, 5D2, 6D2. So this is going to be the answer. Xenon, you know that? Agreed. Let me check it out. This is the answer. God is one. To remember D1 configuration. Next question. Concept of coordination chemistry, valence bond theory. Let's move towards the hybridization. Definitely the most important question is going to come on hybridization only, but for that we should know spectrochemical series. Then only we can do the question. Spectrochemical series is weak field ligand. I am going to tell you IBr after this. All these are weak field ligands. All these are being weak field ligands. Now, Adata, ammonia, now En, Cn, CO. These are always strong field ligand. Always strong field ligand. Yeah. Always strong field ligand gets. Always strong field ligands. Now, if I talk about ammonia, if I say about ammonia is a mediocre ligand. Mediocre ligand. Or I can say ammonia always act as strong field ligand, but with this ammonia, if I remove it, ammonia I can say act as strong field ligand, generally act as strong field ligand. But remember my point, this ammonia with nickel 2 plus, iron 2 plus and manganese 2 plus, this ammonia will behave as weak field ligand. Do remember, then only you can solve the question. Ammonia act as strong field ligand, but with nickel 2 plus, Fe 2 plus, manganese 2 plus, it will act as weak field ligand, and these two ligands, cobalt and water, with CO3 plus, they will act as strong field ligand, and these two always strong field ligand. Now see, pick out the correct statement about manganese CN6. CN to cyanide to always strong field ligand. Manganese, what is the atomic number of manganese? Manganese is 25. So we can write 2 5, just reverse it, 5 2, 3d5, 4s2. Is it clear? Now manganese 3 negative, that means x minus 6 is equal to minus 3, x is equal to plus 6 minus 3, that will come out plus 3. Oxidation state is plus 3. So manganese plus 3, I have to remove 3 electrons, 2 electrons from here and 1 from here, 3d5, 3d5. Now cyanide is strong field ligand, just under the influence of cyanide the electrons will get shifted toward this side, 1, 2, 3, 4 and 5. Now what will you get? Filling will take place from here. Now the cyanide will start filling electron D2 S P3. What do you think? What answer is? Yes, what's your answer? Just to let me know what should be the answer. What should be the answer? I'm waiting for the answer in the chat section. Yes, yes, you're correct, absolutely correct. Those who got the correct answer, just show me the thumbs up if you got the correct answer. Now see, which one of the following is an outer orbital complex? Outer orbital complex means weak field ligand, weak field ligand. So see to it. These are 3 plus. 3 plus means ammonia will behave as strong field ligand. Always when the oxidation state is 3 plus, ammonia has to behave as strong field ligand. I have told you nickel 2 plus. Nickel 2 plus, with nickel 2 plus ammonia behaves as, ammonia will act as weak field ligand. I have told you right now, with nickel 2 plus ammonia has to behave as what? Weak field ligand, weak field ligand. So this is going to be the answer, because once this is acting as weak field ligand, see to it. Nickel's atomic number is 28, 28, reverse it, 82. Now 82 means what? 3d8, 4s2. Now it has lost how many electrons? Nickel 2 plus. Nickel 2 plus means nickel 2 plus. Nickel 2 plus means electrons will eliminate out 4s, 3d8. 3d8, how can I write 3d8? Because the ammonia here is acting as weak field ligand. 1, 2, 3, 4, 5, 6, 7, 8. How many unpaired electrons? 2 unpaired electrons. So Bohr magneton will come out 2 point something, 2 point something, and this is 2 point something, and this is going to be what? This will get proved as paramagnetic. This is going to be paramagnetic. So what's the answer? What's the answer? Kids, what's the answer? What's the answer? Definitely this is the answer. Now Riemann-Tiemann reaction, Riemann-Tiemann reaction. Riemann-Tiemann reaction is, always to remember Riemann-Tiemann reaction. Phenol. Phenol, if you treat phenol with chloroform KOH, you will get salicylaldehyde. What is salicylaldehyde? Orthohydroxybenzaldehyde. This is being major product because of intramolecular hydrogen bonding, and this is known as salicylaldehyde. This is the most important question for the examination. And if I treat it with CCl4 KOH, alcoholic KOH, I will get salicylic acid. I will get salicylic acid, OHCOH. This is known as salicylic acid. And one more thing, one more important thing, kids. If you react salicylic acid with acetic anhydride or acetyl chloride, do remember, if you react salicylic acid with CH3COCl, now this is acid derivative. Acid derivative will not attack on acid derivative. It will attack over there, and the compound you will get is COCH3. This is known as acetyl salicylic acid. This is the most important question for all the exams. Acetyl salicylic acid. This is also known as aspirin, painkiller. Aspirin, painkiller. Now, at last but not the least, they can ask which intermediate attacks. What's the intermediate? What is the name of intermediate? See how this KOH will release OH negative, and this OH negative will attack on acidic hydrogen of chloroform. It will attack on acidic hydrogen of chloroform, and you will get C, Cl, Cl, Cl negative, and this chlorine will go along with K positive, KCl. Now what intermediate you have got? You got CCl2, dichlorocarbon, the actual intermediate. Actual intermediate. This is the electrophile, actual electrophile. They can ask. Till now, is everything clear? Just do let me know in the chat section. Till now, everything is clear. Show me thumbs up. Everyone, show me thumbs up if till now everything is clear. See, here is the question. Here is the question. I want to see thumbs up, likes in the chat section. If everything is clear to all of you, if you are able to understand each and everything, just show your love, affection and thumbs up in the chat section. Wow, that's really awesome. Now, what question they are asking? The reaction the electrophile produced is, they are asking for the electrophile. Electrophile, what should be the electrophile? Dichlorocarbon. I have told you dichlorocarbon, and remember that it's not a nucleophile. If you see like this and people start calling this, there is a lone pair. No, it is electron deficient. Electron deficient species. Electron deficient species. So it is having only 6 electrons. Only 6 electrons. Right? Next question. Reaction of phenol with chloroform in presence of dilute sodium hydroxide finally introduces which one of the following functional group? Which functional group? Reaction with chloroform. What I have told you, see the reaction. See, here I have explained chloroform and KOH. Which extra group you got? Which extra group you got? Which extra group you got? So what's your answer? What's your answer? Hey everyone, just do let me know the answer. What's the answer? So definitely this is going to be the answer. Increase your speed. If you are getting the answer, just quick, fast. I want to see the speed. Yeah, this is the answer. Concept of Williamson synthesis of ether. This reaction definitely it is going to come in your exam. Riemann-Tiemann reaction and this reaction, they are really very important reaction. Very important reaction. Definitely it is going to come in your exam. Now, this Williamson synthesis, one more thing. Even cleavage of ether. Once the ether is formed, cleavage of ether is equally important. Cleavage of ether, this is really very important. Either the question will come from formation of ether. This is formation of ether. Williamson synthesis is for formation of ether. Once the ether has been formed, cleavage of ether. These two concepts are really very important. Let me tell you both the two concepts. See to it everyone. Whenever you are provided with Rx, see who is there. Whenever you are provided with Rx, I am going to tell you Williamson synthesis, Williamson's synthesis of ether. Rx, this Rx should be 1 degree or 2 degree. Can't be 3 degree. It can't be 3 degree, otherwise elimination will take place. Now what happens in this? Rx reacts with RONA or ROK in the presence of dry ether, that is polar aprotic solvent. You will get ROR dash. It can be written like this, or it can be, let us take R dash OR. So this is ether, symmetrical or unsymmetrical ether. Is it clear to all of you? Now see to it. We can prepare any ether. For example, C2H5Cl, and we are reacting with CH3ONA, we will get CH3OC2H5. Now let me tell you the cleavage of ether. Then you can do any question. Cleavage of ether. See to it, cleavage of ether. Always remember, whenever any ether is provided to you, whenever you are reacting it with HI, this is being strong acid, the cleavage will take place due to acid-base neutralization. Acid-base neutralization, you are going to get CH3, O positive H oxonium ion and C2H5. Now, first of all, always think for SN1 reaction. If SN1 is not possible, then go for SN2. Remember this point, always think for SN1. Always go for SN1. If SN1 is not possible, then go for SN2. Second choice is SN2. Just keep it in your brain. First choice is SN1, and if SN1 is not possible, then go for SN2. Are you getting my point? Now, what is required for SN1? At least either on this side or that side, carbocation must be stable. Carbocation must be stabilized by resonance. SBR, full form of SBR is stabilized by resonance, or it must have, or the carbocation must have, or it should have at least 8 alpha hydrogen atoms. 8 alpha hydrogen atoms. How many? 8 alpha hydrogen atoms. Then SN1 will take place. Then definitely SN1 will take place, and I will attack on carbocation. I negative will attack on carbocation. This is the cleavage of ether. See to it. See, anisole. What is anisole? This is anisole. Now this on reaction with HI, neither of the carbocation is being stable. See to it. This carbocation is on benzene, not stable. And that is on being methyl, not stable. So what do you think? SN1 or SN2? This is going to be, I think, last question. SN1 or SN2? Do let me know in the chat section. SN1 or SN2? Neither of this carbocation is stable, nor of that carbocation is stable. So definitely this is going to show SN2 reaction. And in SN2 reaction, I negative is the nucleophile, will attack on least sterically hindered. Will attack on least sterically hindered. Who is least sterically hindered? Methyl is least sterically hindered. So I am going to give you the trick for it. Brilliant, awesome trick. See to it, everyone. How can you do this question within fraction of seconds? This I and this H, you got phenol and methyl iodide. Phenol and methyl iodide. phenol and methyl iodide, anisole, phenol and methyl iodide. This should be the answer. This should be the answer. Clear to all of you? Check it out. Yeah. Now, the heating of phenyl methyl ether. Question is same concept, phenyl methyl ether. Phenyl methyl ether. This is nothing other than anisole. This is once again anisole. Anisole. Remember that anisole with HI. HI. Same concept I have told you what will be the answer. Just to let me know what will be the answer. Yes, everyone, be quick, fast. Let me know what should be the answer. Definitely phenol is going to be the answer. Yes. Now, this is the most important question. What answer you are going to get, just to let me know in the comment section, chat section. See, this is compound. This hydrogen is being acidic hydrogen, and this is reacting with NO, O negative Na. This is ionic bond, and strong base, because oxygen is having negative charge, so definitely it is being strong base as well as nucleophile. There is no acidic H, so definitely it will behave as nucleophile. Methyl iodide, see how the reaction has taken place. Na has gone with iodide negative. This is Williamson's synthesis of ether. Williamson's synthesis of ether. You got ether. Now what should be the answer? Just to let me know. Okay, this is the last question. What should be the answer? What answer should I mark? Everyone, this is the last quiz for organic, and after this Shreyas sir is there along with me right now, and after this physics session is going to get started. So this is the last question for chemistry. Everyone, do let me know in the chat section what answer you are going for. Williamson's alcohol synthesis. Williamson's, see, the examiner can also give you Williamson's continuous esterification. No. So the answer is Williamson's synthesis of ether. So I think this is the answer. Yeah. So this was all about chemistry. These were the important concepts. Now I will call our lovely Captain Sir.
Yeah, sir, you can continue talking. I'll just save your.
Yeah. Okay. So you got some tricks. God is one. And about with iron, man, nickel, if they are in +2 oxidation state, ammonia will behave as weak field ligand. Otherwise, ammonia is strong field ligand. Yeah, Captain Sir is there. Okay. Just wait for 1 minute, and you can see the love for Captain Sir. So you got some tricks of chemistry, and definitely you are going to rock in physics also. Then afterwards bio. So everyone, how's the Josh? How is the Josh? Do welcome your Captain Sir. And if you're new on this channel, Unacademy NEET English channel, do subscribe the channel. We want your love and support. Kids, without you people, we are nothing. You are the people. Once you are becoming doctor with best marks, then only world is going to recognize us. So we are definitely day and night, we are putting our all the best efforts, and we need your support. If you have not liked, just to like the hit. Yes, everyone hit the like buttons. And if you're new, do subscribe the channel. So, Capto is waiting.
Thank you so much, sir. Thank you so much. What a lovely session, guys. Thank you so much for making it 1K likes. Let's make it to 2K likes by the time the session ends. So we need your continuous support, and not just that, we have now crossed 20,000 subscribers. Thanks to your love and support. I want this.
Just 1 second. If you think your physics is, yes, physics is looking tough, your Capto is going to make it Romba Sulbam. Okay.
Yo, nice, good one. That's good Tamil, sir. And yeah, I want that subscriber count to go up to 21K, because the more, the merrier, the better, the higher Josh we get to conduct more classes. Thank you so much. The only reason we are continuing is only because of your love and support. Remember that, my dear warriors. So it's time to start physics. Are you guys ready? Today's session will be a little bit on the higher speed side because time is less. Your city announcement is done. Admit cards will be out soon. Saturday you're not supposed to study. So obviously it's time to buckle up and fasten your seat belts. Thank you for smashing the like button as well. So today's learning outcomes, guys, right from these are the top 60 topics. Out of that, many topics, almost more than 25 topics have been done. After this, I think more than 50% of the 60 topics would be done by today. So that's the crazy part. So right from thermal expansion, Stephen's law, Wien's law, Newton's law of cooling, conduction of rods, escape speed, Kepler's law, standing waves and organ pipes, beats and Doppler effect, wave speed on a string and sound. So these are the topics that we'll be doing out of the top 61. Okay, if you have not watched my previous videos, please do check out the marathon sessions. I have taught to you many subtopics over here out of those top 60 topics. Let's begin. Hello Suresh, Manohar, PDK, Devil. Hello Suman, hello Aswat, nice to see all of you, and Srividya thanking this already. You will get more than 150 plus if you study all the 60 topics. If you are just attended my marathons alone, at least 100 marks, guys. Yep, great, awesome. Hello Dashli. Yes, there will be a session for full formula revision for all the topics as well. Definitely. So it's time to begin the class with thermal expansion. If you heat something, it expands. Heating leads to expansion, cooling leads to contraction. So the moment you heat something, it expands. The moment you cool something, it basically contracts. Now, if I am given some rod or some object, let's say of length L, let's say this is a temperature T naught, or let's say this is length L naught. This is at some temperature T naught. If I heat it, it will expand, and let's say the rod looks like this. It becomes longer like this. This is at temperature T. This is the final length L. Then what is the relationship between them? The final length is the original length into 1 plus alpha delta T. What is this alpha? Alpha is coefficient of thermal expansion. Coefficient of thermal expansion, but this is linear expansion, so you can also call it linear coefficient of thermal expansion or coefficient of linear thermal expansion. Linear because it is along the length line, so that's why linear. You can also rearrange this. By taking L naught on this other side, and finally it also becomes delta L is equal to L naught into alpha into delta T. So this formula also comes from this formula. Either this or this is fine. This delta L represents the change in the length. What does it represent, my dear warriors? Change in length. Okay. Now you might be wondering, what is L naught? L naught is original length. Okay. I hope this is fine. What is delta T? Delta T is the change in the temperature. So it is basically T minus T naught. Basically your temperature difference. Is that okay? Everybody with me? Awesome. Just 1 second. Your chats are not seen so clearly. Just 1 second. Let me get it here. Just 1 second, guys. Let me get your chats. No, it's fine. Yeah, this session will be maximum 1.5 hours, not more than that. Okay. From 60 topics, I already mentioned, Shant, you will get around 140, 150 marks. Please watch the videos, guys. It's all there. You guys don't make that effort of seeing the channel. You want everything in the chat box. Please explore the channel. Everything is there, guys. Everything, the strategy I have mentioned, what topics you have to do I have mentioned, what should be the timing strategy I have mentioned, everything is there. Please, my humble request, that's why you should hit the subscribe button. You should know what is going on in the channel. Every piece of information is there for all of you. Explore the channel because it is your channel, remember that. Now, this is linear. There is also the two other types of expansion. The second type is basically aerial expansion. So, if you have certain area A0 at temperature T0, you heat it, what will happen? The area will become larger. The area will become larger. This is at temperature T, the area is A. Similar to the previous formula, instead of L you put A, it will look like this. A0 1 plus, instead of alpha put beta delta T. This is the coefficient of aerial expansion, coefficient of aerial thermal expansion. So, because area is involved. Also you can say delta A, also delta A will be A0 beta delta T. How many times is beta of alpha? Beta is how many times of alpha? Let's see how many of you remember this. How many times is beta of that of alpha? I want everybody spamming the answer in the chat box, guys. Come on. So imagine, meanwhile I will draw the next diagram. Imagine you have some volume V0 at some temperature T0. Okay, you heat it. So the volume becomes larger. It becomes V. This is at temperature T. Then this volume will be V0 1 plus gamma delta T. Very similar looking formulas, and change in volume will be V0 gamma delta T. So this gamma is the coefficient of volume expansion. Very good. I can see the answers coming up in the chat box. Perfecto. Perfecto. This is 2 times. Can somebody tell me gamma is how many times of alpha? Gamma is how many times of alpha? My dear warriors, gamma is how many times of alpha? Come on, spam the answer. It is very good. 3 times. Excellente. Excellente. So, no guys, no Monisha, this is not from ground zero. This is in little bit fast mode. Understand? This is just 1 week before the exam. What do you think? You expect me to do right from basics? Then that is wrong. If some teacher somewhere is doing right from ground zero, then you're just wasting your time, guys. It's not right now. It's just 1 week. Do you understand? There were many years, there were many months. So now I'm going to tell you how to apply those formulas. Now I'm going to tell you how to apply those concepts. We are going to revise through it. I will save your time. Okay, even if you do not know much, just listening to the lecture, you will get something. You go home and practice problems. Trust me, that will help you. Rather than studying everything at the last moment. No, this is not the time. Sometimes I need to tell you the harsh reality, guys. Or else you are getting used to listening very good things. I will motivate you, but you should know what is exactly happening around you. Or else you will tell me after the exam, sir, you lied. Sir, you told that we have to do this. I will teach you from basics. Sir, what is this, sir? You wasted time, sir. No, sir. So I don't want that, guys. And you know that how we have been. If you have been associated with me for more than 2-3 years, you know how we are. We just tell you whatever is there, you know, in our heart and in our mind, right? So that's important. All right. So next important thing, guys, over here is that these problems generally involve either finding changes in volume, changes in area, changes in length, and sometimes also density changes can be asked, because if volume expands, the mass is spread on a larger volume, the density will go down. So sometimes they might ask you, what is the change in density, right? I hope this is clear. So I think it's a good time we start solving problems on this particular topic. And here comes the first question on your screen. The coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Lengths of brass and steel rods are L1 and L2 respectively. If L2 minus L1 is maintained for all the temperatures, which of the following relationship holds true? Come on, think about it, my dear warriors. Think about it, my dear warriors. What should be the answer for this particular thing? Come on, figure this out. What should be the first step of this problem? What should be the first step of this problem? Both the rods have different alpha. Both the rods different length. But their changes in length should be same because the difference in their lengths is same. So if this is one rod, this is another rod. This rod expands this much. This rod expands this much. If this was the difference before, now this is the difference. So if the difference is same, that means the expansion is also same. So delta L1 will be delta L2. What is the formula for delta L? I just gave it to you. It is original length, which is L1, into coefficient of thermal expansion, which is alpha 1, into the difference of the temperature. Same way for delta L2, the original length, which is L2, coefficient of thermal expansion, which is alpha 2, change in temperature, which is delta T. Delta T, gone. So L1 alpha 1 will be L2 alpha 2. Let's see if there is a matching option. L1 alpha 1, L2 alpha 2. A for AFMC, A for aims. Which aims are my warriors aiming for? Which aims, or maybe some of you want to go into army and AFMC? From my hometown, guys, Pune. Yeah, I always feel proud when somebody says I want to go to AFMC, and that too from my hometown, Pune. It's crazy, guys. Awesome. Let's move on. To the next question on your screen. The value of the coefficient of expansion for glycerine is 5 10 to the power minus 4. The change in the density of fractional change when you change temperature by 40 is how much? A lot of you saying Kalyan, CMC, Delhi, Bhopal, Rishikesh, Pondicherry, crazy. AFMC is love. AIMS is also love. Calicut Medical College, look at that. Oh my God, I can see doctors everywhere in India, yaar. I can see doctors everywhere in India coming up from this channel. Thank you so much, guys. Means a lot. Thank you for subscribing also. Okay. So, how do we do this? Fractional change in density means what? Change in the density by original density. Now, you'll be like, sir, how do I get this, sir? Don't worry. Shreyas, sir, your captain is here. What is the formula for density? Density is mass by volume. Now, you will start wondering, sir, how do I get this? I know that. How do I get this? Then suddenly you will eat Mentos. And suddenly your bulb which is there inside your head will start glowing. Then you will realize, oh my God, this problem is not just from thermal expansion, it is also from units and dimensions errors. But how? Observe. Take the volume up. V raised to minus 1, this is M raised to 1. Now I know what else to do. Use the relative error formula. This is density mass raised to 1, V raised to minus 1. So del rho by rho, mass is constant. Mass is not changing. Mass is the same. So this is basically a constant. So it is basically that minus 1's modulus into delta V by V. Always take the positive power. Hence the modulus, yes or no? Now if this much is clear, what is delta V by V? Acha, delta V I know. What is delta V? It is original volume gamma into delta T. V will cancel. I will get gamma delta T, yes or no? Very nice. Do I know gamma? I think I know gamma. It is 5 into 10 to the power minus 4. Do I know delta T? Yes, it is 40. 5 4s are, come on guys, 20, and this 0 and 10 to the power minus 4. So it will be 2 into 10 to the power minus 2. 2 into 10 to the power minus 2. Where is the answer? C for Capto. Excelente. Very good. Champa is also smiling. Champa felt bad yesterday that I didn't draw Champa. It's okay, Champa. I will draw you in the next marathon when I give you a break. Yeah. Next concept which is very important is Stephen Boltzmann constant, my dear warriors. Crazy name, no? Stephen Boltzmann. That's not the name of one guy. Yeah, two people made it together. Team, just like Avengers is a team, right? So Stephen and Boltzmann gave a very interesting law, and what did they say? They said if you take a hot body, let's say for example, maybe we can draw Champa today. This is very hot Champa. This is very hot Champa. Very, very hot Champa. है ना? Every guy has a crush on this hot Champa. Not like that, yeah. Hot Champa means her temperature is more. What were you guys thinking? Concentrate, guys. NEET exam is after 1 week and you are saying something and all. है ना? So her temperature is very high. Okay, she has fever. So that's why she is called hot Champa. Understood? Temperature is high. Why? Because she has fever. Got it? Very good. Now let's say the temperature of Champa is T. Let's say the area of Champa. Now don't ask me how I calculated the area and all, but we know that the area of Champa is A. She radiates, not love. She radiates heat, energy around her. Understood? She radiates heat around her. So heat is coming, body heat. If you go close to Champa, you can feel she has fever, corona, some disease she has. Okay. So there is some amount of heat which is radiating from her. That is radiation, guys. So wireless. It is wireless. Hai na? Like corona was also wireless. You don't have to connect. You don't have to touch also. You just breathe close to that person, gone. COVID positive. So same way. Radiation is also wireless mode of heat transfer. So the amount of heat which is radiated by Champa, this hot Champa, will be given by these two people. So what did these two people say? The amount of heat which is radiated per unit time, Q by T, heat per unit time. So joules per second, watts, that is in watts, okay, will be E sigma A T raised to 4. What is A? Area. What is T? Temperature. In which unit? Celsius? No. Fahrenheit? No. Which one then? Obviously the remaining one, Kelvin. Got it? Always use Kelvin. Don't put Celsius or else you will say 0 degrees Celsius, 0 heat. No. 0 degrees Celsius is actually 273. So still heat is radiated. Only at 0 Kelvin, no heat is radiated. Keep that in mind. 0 Kelvin, no heat radiation. Any temperature above 0 Kelvin, even inside the fridge, heat is radiated. Like crazy, mind blown. Hai na? In the fridge also, heat is radiated because the temperature is above 0 Kelvin. Anyways, so what is this E? E is basically your emissivity. Emissivity. So my dear students, for black body, emissivity is 1. Emissivity is 1. Black body. So for normal objects like me, Champa, Pandu, table, cloth, stone, hai na? The E value will be less than 1. E value will be less than 1. Very nice. And what is this sigma? Sigma is a constant 5.67 into 10 to the power minus 8. Very easy to remember. 5, 6, 7, 8. 1, 2, 3, 4. Get on the dance floor. You might have heard that song. So like that 5, 6, 7, 8. Stephen Boltzmann constant. That is the new song. 1, 2, 3, 4. Get on the dance floor. 5, 6, 7, 8. Boltzmann constant. Understood everyone? Understood everyone? 5.67 into 10 to the power minus 8. So imagine Stephen and Boltzmann dancing. Stephen Boltzmann dancing. So 1, 2, 3, 4, get on the dance floor. Stephen Boltzmann is saying 5, 6, 7, 8, Stephen constant. Something like that. Some very bad joke, guys. But anyways, I hope you remember it via this joke at least. Great. Thank you for all the love, Vasu. I hope you guys are doing great. Yeah. So moving on to the next part. Sometimes you might have to use this value of Q like this. Q is equal to MC delta T or NC delta T. This is for gas. This is for gas. This is for solids and liquids. Solid or liquid, generally you will use this. Here N is moles, here M is mass. Here C is specific heat capacity, here C is molar specific heat capacity. Temperature change, temperature change. Q is heat. Sometimes you might have to use this. Or you might even have to use M into L. L is latent heat. L is latent heat. L is latent heat. Understood? Yes or no? Okay. Champa is very happy that Capto is drawing her with fever also. Great. So M into L. M is mass. L is latent heat for transformation. Ice into water, water into steam, steam into water, water into ice. So that latent heat L, okay, sometimes can be used over here. Very rarely such problems come, but I am telling this to you. Cool. I think we can solve some questions. I think we can solve some questions. Coming up on your screen, here it is. Spherical black body. Just like Champa only. Radius 12 centimeter. radiates 450 watts power 500 Kelvin. If the radius were halved, temperature doubled, then the power radiated would be how much? That is the question. Read it again 1-2 times, you will probably start to see what we have to do. Radius is R, it is radiating heat, temperature is T. So what is the rate at which it radiates heat? Which is basically the power. It will be E sigma A T raised to 4. E black body means E is 1 sigma A. I will put it as 4 pi r square. Like, sir, why 4 pi r square? Look at this. Radius is 12 centimeter. What is it? Sphere. What is the surface of a sphere? 4 by r square. 4 pi r square surface area. Volume 4 by 3 pi r cube. This is 4 pi r square for the area into T raised to 4. Done. Okay. Now what is it? If radius is made half and temperature is doubled. Okay, so this was the power before. Now for the new situation, P new will be 1 into sigma into 4 into pi into radius is halved. So instead of r, put r by 2 whole square. Instead of t, put double. So put 2t raised to 4. So this will become 1 into sigma into 4 pi into r square into t raised to 4 divided by 2 square 4. 2 raised to 4. 4 into 4, 16. So 4 and 16 goes, this becomes 4 times. Now this 1, sigma, 4, pi, r square, t raised to 4, that is p, no? That is p, yes or no? P for Pandu. So Pandu comes over here, and what is this? Only into 4. So power into 4, what was the power? 450. 450 into 4, 45 2s are 90, 45 4s are 180. So 180 and add that extra 0, that many watts. 1800 watts. Excelente. That is option D. D for doctor. Very good, it's Priyo. Excelente. Yes, Arya, Champa is a girl name. Definitely. Pandu is the boy. He's the hero. She's the heroine, right? Everybody adores them. Everybody is pagal, crazy about them. Okay, chalo. Let's go to the next question coming up on your screen now. Here it is. The total radiant energy per unit area in the normal direction received at a distance r from the center of a star of radius r whose outer surface radiates as a black body, temperature T Kelvin, sigma is Stephen's constant, is, this is little tricky. Lot of people in this NEET paper would have done some or the other jhol mistake. Okay, so we'll do that. Let's see if you guys can do this. Okay, first let's visualize. Imagine a sphere of radius small r, It starts radiating energy in all the directions. Like this. Okay. Now, if you are at a distance of capital R from the center, so just imagine a big imaginary sphere like this. Okay. This is basically capital R. The question is, what is the energy per unit area? What is the energy which is coming per unit area? Per, let's say, for example, unit time also should have been there. I think this should be radiant energy per unit area. Per unit time also should have been then. So the question is, what is it at this particular point? First, let's calculate how much energy is coming. Per unit time. So how much energy is radiated per unit time as per Stephen's law is E sigma A T raised to 4, but E is 1, so 1 into sigma into A into T raised to 4, but area we know is the surface area. Surface area of the star, what is the surface area of the star? 4 pi, but that is small r square into T raised to 4. So that is your Q by T value. Everybody with me? Very nice. But that is not the question. Question is per unit area. So this heat per unit time per unit area of this big sphere. So just divide this total energy which it gets All this energy is reaching the sphere. So per unit area, how much energy is coming per unit time? So just divide this entire number, which is sigma into 4 pi r square into t raised to 4 upon the total area of this sphere. Total area of this sphere, because we have to find what is the energy per unit area on this point. So divided by the area of that sphere, which is 4 pi r square. 4 pi gone. So it will be sigma r square t raised to 4 by capital R square. Capital R square. I think this should be the answer. Where is it? Option B. Yes, it is. Look at this. Option B. Sigma r square t raised to 4 by capital R square. Perfect. Perfect. Great. Understood? Clear? Arey wow, very nice. Vasu is from Kurnool. A lot of my people whom I know are from Kurnool also, in my relatives. Crazy. B for Bahubali is the correct answer. Awesome, 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 awesome. Moving on to the next question coming up on your screen. Before that, the Wien's displacement law. What did this Wien guy say? This Wien guy said, if you draw a graph of, let's say for example, wavelength versus energy, then that graph looks something like this. That's what he said. He said that there is a particular wavelength which is maximum in number, in maximum amount. Like for example, imagine there is one wavelength of 400 nanometer, another wavelength of 500, another wavelength of 700. There are different wavelengths which will come out of a body which is hot. Hot body radiates energy. But there is one particular set of wavelengths which are very common at a particular given temperature. So let's say 500 nanometers is lot in amount. 400 is there sometimes it's 800, sometimes 700, sometimes 200, but one particular wavelength is there in large quantities, so their energies proportion is more. So that point is called lambda max. That is not the maximum wavelength. A lot of people read this as maximum wavelength. No, this is not maximum wavelength, my dear warriors. This is the wavelength for which the energy is maximum. Understand the difference. Now, if you heat this body, then this curve shifts like this. This curve shifts like this. So this lambda max also displaces. That's why Wien's displacement law. So this is for higher temperature. This is for higher temperature. Now Wien found out this graph for different temperatures and he gave the following law. The law is as follows. He said that this lambda max into the temperature is always constant for a black body. For a black body radiation, he found that this is a constant. It's a constant. So if you increase the wavelength, temperature will have to be less. Or if you increase the temperature, then wavelength has to be less. Understand that. So you can see the moment the temperature goes up, the peak value which comes is at a lower wavelength. The maximum energy comes at a lower and lower wavelength. Is that clear? Everyone? Everyone with me? Everyone with me? Excelente. Excelente. Tamil Makkals are also here. Wow, great. Pasangla is also here. Makkals are also here. All the Ras and the Das are also here. Very good, very good. So many people from Maharashtra also. Are bhau, kaisa hai? Majama is also here. Okay, very good. Chalo, let's move on then to a question coming up on your screen. Okay, alright. So, 3 stars A, B, C have surface temperature TA, TB, TC. A appears bluish, B appears reddish, C appears yellowish. We can conclude that. What can we conclude? Come on, my dear warriors. Yes, think about it. Now, if these are stars, the temperatures are different. A is blue. Blue is the shortest wavelength. B is red, longest wavelength. C is yellow. So, if I have to arrange it as per the wavelength, bluish is the shortest wavelength. So, I'll put A first. then comes yellow, that means C. Okay, C is little bit larger, and then comes B. So this is as per wavelength, but we know that lambda into temperature is constant. Basically, temperature is inversely proportional to the wavelength. So if I have to talk about the temperature, the order will be exactly opposite. So A will be more than C will be more than B. Yes or no? So where is the correct option? A, C, B. That is option D. Exactly, D for doctor. Perfecto. Understood? Exactly inversely related to the wavelength. You should know who is larger wavelength, who is smaller wavelength. That's a part of electromagnetic waves. Okay. There is a body. Temperature is 5760. Energy of the radiation is 250 for U1, 500 for U2 and 1000 for U3. Wien's displacement constant is also given. Which of the following is correct? The energy emitted by the body, okay, for wavelength 250 is U1, 500 this is U2, 100 for U3. The question is, which one of the following is correct? Come on, my dear warriors, think about this. Think about this. Which one will be correct? So, like I said, lambda is inversely proportional to temperature, or temperature is inversely proportional to wavelength. Alright. So, think about it. Over here, U1 is having the least wavelength. So, U1 is having the least wavelength. So, my dear students, the U1 value will be the highest. Then comes U2, which is having a little bit higher wavelength, so smaller energy. Then comes U3, which has the maximum wavelength. So, this is U3. So, U1 more than U2 more than U3. So, that should be the correct answer. So, U1 is more than U2. Is that clear, my dear warriors? Everybody with me? Great. Let's move on to the next concept then. Very nice. Let's move on to the next concept. Great. Chalo. Let's see what is Newton Baba's law. Newton is there everywhere. He's there here also, he's there also, optics also is there, he's there in thermal physics also, everywhere. He was not married, you know. So that's why he got all the time. Okay. All right. I have not taken your name, Yuvan, as of now. Okay. Chalo. Let's see. What did Newton Baba say? Newton Baba said that in the morning, when Pandu goes for having bath, okay, and he has filled hot water in the bucket. He has filled hot water in the bucket. What he finds is very interesting. If, example, the water in that bucket was at 60 degrees Celsius, if it cools down to 50 degrees Celsius, maybe it takes 10 minutes, example, maybe it takes 10 minutes. But to go from 50 to 40 degrees Celsius, do you think it will take again 10 minutes only? Or do you think it will take less time? Or do you think it will take more time? What do you think? From 60 degrees to 50 degrees for it to cool, it took 10 minutes. From 50 to 40, more 10 degrees change. How much time do you think it will take? Still 10 minutes, or less than 10, or more than 10? Akit saying less than 10. What about others? More than 10, says Just Jane. Nekar Shah saying no, more. Pani Puri saying 20 minutes. Yeah, Pani Puri saying 20 minutes because 10 minutes you take time to eat Pani Puri. No, so 10 minutes to cool down, 10 minutes to eat Pani Puri. So total 20 minutes. Very nice. So correct answer is more than 10. Yup. So it takes more than 10 minutes. Why this happens? It's because of Newton Baba's law. He says more is the difference between the temperature of the body and the surrounding. Surrounding is maybe 20 degrees Celsius or 30 degree. More is the difference, faster it will cool. Small difference, slowly it will cool. Now when it is hot, the difference of the temperature between this and the outside temperature is large. So it will cool fast. But moment it becomes cold, it cools slowly. So the closer it comes to the actual surrounding temperature, it cools slowly. In fact, the graph of the cooling looks something like this. The graph of cooling looks something like this. If this is time and if this is the temperature of that body, then that graph looks something like this, my dear students. Look at this, crazy. This is the surrounding temperature. This is initial temperature of that body. Initial temperature of that body. This is very important. If by chance you happen to draw a tangent to this curve, okay, if you draw a tangent to this curve, guess what? The slope gives you nothing but, or the magnitude of that slope gives you nothing but rate of cooling. Rate of what? Cooling. Basically, it gives you nothing but change of the temperature. So, the change of the temperature of that body, or I can just put it as dT upon dt. This stands for temperature, this stands for time. Now, many books don't want you to confuse between both the symbols T, so they use theta instead of temperature, capital T. That is also okay. That is also okay. Is that okay, everyone? So, dt, change of temperature upon time, 10 degrees Celsius per minute, 5 degrees Celsius per second. So, that is the meaning of rate of cooling. So, according to Newton Baba, what happened, bachcha log? According to him, this dt by dt is proportional to the temperature of the body minus the temperature of the surrounding. Basically, that dt by dt is some constant into temperature of the body minus temperature of the surrounding. That's what he said, simply put. Now, how do we use this formula? I will show it to you. Let's learn this. Everybody, expect a question on this. If it comes, you will remember me and you will solve it within seconds, but practice more, 1 or 2 questions at least after this session, so that this registers in your head. Whatever questions I have practiced now, practice similar question. Practice again similar question. Trust me, it is very important. Okay, chalo, let's do some questions. Arya, what uncle? Yeah, he was there 300 years ago. I think I should call him grandfather. Great grandfather. No uncle binkle and all. Next level he is. Okay, an object kept in a large room having air temperature of 25 degrees Celsius takes 12 minutes to cool from 80 to 70. Time taken for that object to cool from 70 to 60. Very similar problem to what I gave you. Okay, let's try to understand first. Okay, so the initial temperature was 80 degrees Celsius. This is for the body. This is for the body. Then it goes to how much? 70 degrees Celsius. Then it goes to how much? 60 degrees Celsius. The first event happens in how many minutes? It takes 12 minutes. So, how many minutes? 12 minutes it takes, correct? The next event happens, I don't know, I'm just going to put T minutes over here. I don't know that. Meanwhile, what is the surrounding temperature? The surrounding temperature, it is clearly mentioned as 25 degrees Celsius. The surrounding temperature is 25 degrees Celsius. Now, for the first time, okay, what is the rate of cooling? Change of the temperature, which is 80 minus 70 upon the time, which is 12 minutes, is equal to constant temperature of the body minus temperature of the surrounding. What is that surrounding temperature? It is 25. It is 25. Remember, always this should be your surrounding. This should be the temperature of the body. This is your rate of cooling. This is the rate of your cooling, correct? This is how it works. What should be the temperature of the body? Let's see how many of you can answer this. I am waiting to listen into your answer, my dear warriors. What should the temperature of the body be put? Should I put it as 80? Should I put it as 70? Or do you think I should put it as something else only? What should I put it? 80, 70 or something else? First it was 80, then it was 70. It's taken a long time. In that duration, what is the one value of temperature that I can take? Exactly, Arvind. Take neither 80 nor 70, take the average. Yes, always take the average. Very nice. So, what is the average of 80 and 70? Yes, it is 75. Understood, my dear warriors? It is 75. So, 80 minus 70, that is 10 by 12 is equal to constant divided by 75 minus 25, that is basically your 50. Very good, very good, very good. Next important thing, for the second event, what is the change in the temperature? from 70 it went to 60, and how much time it took, I don't know, is equal to constant. What is the average temperature between 70 and 60? 70, 60, 65, right? So 65 minus 25. Yes or no? Very good. So 70 minus 60, 10 divided by T is equal to C. 65 minus 25, just do the math, it will be 40. Very nice. Now what do you do next step? What should your next step be? Take this equation and divide both of them. Divide both of them, okay? Just divide both of them. This with this. 10, 10 by. 10, 10 by. In case you are not able to see, just put it over here. 10 by 12 divided by 10 by T is equal to C into 50 divided by C into 40. 0, 0 gone. 10, 10 gone. T goes on the top, 12 comes below. T goes on the top, 12 comes below. Here CC also gone. This is 5 divided by 4. 4 and 12 cancels, becomes 3. So T will be 5 into 3, which is nothing but 15 minutes. 15 minutes. Where is the answer? Option D for doctor. Very nice. So many of you answered it. Panipuri answered it. Nishkarsha answered it. Likit. Yeah, I think that was the previous one. That is wrong. Average temperature, you will take it as 75, bacha. Very good. Very good. Awesomeness. Ziyad, very good. Very good. Shino, very good. Akshita, very good. Saira, very good. Sanya, very good. Yuvan, very good. Jangam, very good. Excellent. Soda, very good. Vaishali, excellent. Pandu is still in love with Champa. Great. All the answer using my trick. Yeah. Guys, if you use my trick also, you will get almost similar answer. Matlab, 10 is the least answer, 20 is the maximum answer. So somewhere it should be either 12 minutes or 15 minutes, the median value, right? So if I had to guess the answer, I will either mark B or D. If you have not watched my trick session yet, please watch it right away right now. Boost your score by at least 10 to 20 marks here. Okay. Moving on to the next concept, conduction in rods. Let's move on. Now for conduction. Conduction means the heat is flowing within the solid. So if I take a rod like this is area A, this is having a length L, and I send in heat from one side, it comes out from the other side. I send in heat from this side, it comes out from the other side. Okay. So heat in and heat out both are equal. So the heat flowing in per unit time and the heat flowing out per unit time both are equal. I'll just call it as Q by T, which is also called as the heat current. What is it called? It is just called as the heat current. Keep this in mind. Very, very crucial. Now this heat current, this Q by T is given by K A, then difference of the temperature divided by the length. Heat current is K A delta T by L. This K, this is K, okay. This K is basically called as the conductivity of the material. Conductivity of the material. Very, very important. What is delta T, you might ask? Delta T is the difference of the temperature. So between these 2 points, there will be some temperature difference. These ends. This is at 100, this is at 50, this is at 200, this is at 180. So the difference of the temperature is delta T. Is that clear? Thank you, Saira Nishad, for all the fire and the love. Thank you so much. Okay. Now this is one way of looking at the formula, but you can also rearrange the formula a little bit. Rearrange the formula a little bit and see some magical things happening over here. So what I can do is I'll just write it as delta T. Just take delta T over here. Take L on that side, put Ka below. Take L on the upper side, put K and A below. And Q by T, you can just put it over here. Q by T over here. Now look at this, the way I'm going to write it, my dear warriors. I'm just going to write it as, this is temperature difference. This is temperature difference is equal to something into, this is basically heat current. This is basically heat current. Does this ring a bell? Yes, I think so. Current electricity. Voltage difference is resistance into current electricity. Delta V is I into R. Same way, temperature difference is what into heat current? Obviously the equivalent of resistance in heat, in thermo. So that is basically your thermal resistance. Thermal resistance. Thermal resistance. So my dear warriors, what is the formula for thermal resistance? Thermal resistance, the formula is basically L by Ka. L by K. That is the value of the resistor equivalent for thermodynamics. Where can you use? You can use it for rods in series. Oops. You can use it for rods in series, my dear warriors. Yes or no? Rods are there in series. So that is series combination. You can just add the total equivalent is just R1 plus R2. Similarly, if there is one rod here and there is another rod here, these are rods in basically parallel. So this will be 1 by R is equal to 1 by R1 plus 1 by R2. Yes, everybody? Correcto? Very nice. Excellent. So this slide is also very important. I think we should start with some questions. Are you guys ready for starting some questions? Everybody with me on this? Okay, let's start now. Here comes the first question on your screen. There is a cylindrical metallic rod in thermal contact with the reservoir at two ends. Heat conduction is Q in time T. Now the rod is melted, and then what you do? You basically reform it into another rod of half the radius, but the length is I think same. How much new heat? Oh, the length will also change definitely. So how much new heat will be conducted by that new rod when placed in contact with the same two reservoirs, meaning the same temperature difference. Let's try to do this. Okay, first of all, the heat flow rate Q by T is K A delta T by L. Let's decide which all things we cannot touch. K is a material property, I cannot touch it. The same two reservoirs, that means delta T can't be touched. Area will be dependent on the radius. Length also depends on the radius. I'll tell you why. Observe this. First the rod was like this, no? Now you have made the rod as half the radius. So the radius becomes small. Because you have melted it, the rod will become longer. Length is not constant. Understood? That is the main silly mistake which many students did during this year. So here the volume is basically constant, and volume is basically area into length. So instead of length, what will I put? Look at this, K A delta T. Instead of length, I'll put volume by area. This area will go on the top. It will become K delta T by V into A square. Now instead of A, I can write it as pi R square, that is the area, that's the circular area, whole square. So this will become K delta T pi square divided by V into R raised to 4. The reason for doing this is because I know all these people are constants. The only variable is R raised to 4. So the heat flow rate Q by T is directly proportional to R raised to 4. Now think, the radius is made half. So half raised to 4 is how much? Guys? 1/16. So basically this will also become 1/16 of the times. So if RHS becomes half raised to 4, that is 1/16, the LHS will also become 1/16. Is that clear? Everyone? What a question, right? What a question. How many of you thought about this? Honestly tell me. How many of you would have made this silly mistake also? Let us know. How many of you would have made that silly mistake? I would love to know that. Crazy silly mistake you would have done, guys. Be careful, very, very careful. Okay. Moving on to the next question coming up on your screen now. Two ends of a rod are maintained at temperature 100 and 110. Rate of heat flow in the rod is found to be 4. If the ends are maintained at temperature of 200 and 210, now what is the new flow of that heat? Interesting question. Let's try to analyze. There is a rod, okay, certain length, certain area, first maintained at 110 and 100 in the first case. In the second case, what is happening? The same rod is taken. Now the new temperatures are 210 and 200. Do we know the heat flow rate formula? I think we know. Let's use that then. heat flow rate Q by T is K A delta T by L. Now think carefully, read the question and tell me which things changed, which things didn't change. If the ends are now maintained at this rate, this temperature, what is the new flow? The rod did not change, the length did not change, the area did not change. All these three numbers were constant. All these three numbers were constant. Very good. Let's also calculate what is delta T for the first situation. So for the first situation, what is delta T? This minus this, which is 10. For the second situation, what is delta T? Just calculate it. 210 minus 200, again 10. Oh, even delta T did not change. This is interesting. Even delta T remained, it remained same. It remained same. So what does it mean? Even this will be the same value. What will be that value? This value, 4 joules per second. Hence option A is correct. Okay, great, great, great. Very good, my dear warriors. I hope you guys are subscribing to the channel. Thank you, Aswat, for subscribing. Make sure you spread this channel as much as possible, because this is not my channel. This is not, anybody else's channel. This is your channel. So this is what you would do if you had a YouTube channel, because we listen to you and we are very true to you. We do not make unnecessary comments. We do not give you unnecessary rumors. Many people make rumors also. Okay, oh, the admit card has been released. Oh, that has happened. Oh, this has happened. No. If something has happened, we tell you. If something is not postponed, we tell you. Okay, we do not do random things, because your time is very precious and your mindset is very important. That is very crucial. So the credibility of the channel is something which you should vouch for and which you should look forward to, guys. Because we are the best of the teachers. I'm not boasting myself, but honestly I feel we are the best of the teachers, giving you the quality content for all the subjects. Coming up next is escape speed. Now going on to gravitation, guys. So slowly we are moving to the next and the next chapter. This is Earth. This is Earth. One day Pandu became very depressed. Pandu became very depressed. He's like, why he was depressed, don't ask. I mean, actually there is a side story to that. Basically, he saw Champa with some other boy. So Pandu, heartbroken, gone. After he saw Champa with some other guy, gone, that's it. So Pandu decided, enough, I don't want to live on this planet anymore. I want to escape the Earth. I want to escape this planet. Enough is enough. So then Pandu came to me. He asked, sir, I want to escape this planet, sir. You are physicist. You should know something. I was like, yes, I'll tell you. I told him, listen, if you want to escape the planet now, then you need to project yourself with one speed. That is called escape speed. And he was like, what is that speed, sir? Very simple. Root of 2 gm divided by r. Then he was like, sir, what is this g? G is 6.67 10 to the power minus 11. What is m? Mass of the earth. What is r? Radius of the earth. Wow, very cool. Immediately Pandu took calculator, g 6.67 10 to the power minus 11. Mass of the earth. Sir, what is mass of the earth? 6 into 10 to the power 24. Okay, 6 into 10 to the power 24. Sir, what is radius of the earth? 6,400 kilometers. Okay, into 2 root. What? He was like shocked. Oh my God. Sir, that value for earth, the value for earth, it came out 11.2 kilometers per second. 11.2 kilometers per second. Pandu was shocked. Shreyas sir rocked. Pandu was shocked. Shreyas sir rocked. Pandu was like, sir, how do I get 11.2 kilometers in 1 second, sir? 1 second, I won't even go per hour. If I walk also, I will go like 5 kilometers per hour. So Pandu was like, sorry sir. It's okay, Champa left, no problem. I'll find some other girl. Depression problem solved. So Pandu went back. He did not escape the planet and he found some other girl next day. So that's the moral of the story, guys. Okay, everyone. So this is the very important formula, escape speed. Everybody should know this. And also this escape speed formula comes from the law of conservation. Where does this formula come from? Conservation of energy principle. Conservation of energy principle. That's all. This is how that law comes. Very good. Chalo. Let's start solving some questions. Let's start solving some questions. The escape speed from Earth's surface is v. The escape speed from the Earth's surface is v. The escape speed from the surface of another planet having a radius 4 times of Earth and same mass density, keyword same mass density, is how much? Let's try to do this. Let's find out. First of all, write down the escape speed formula. The escape speed formula is basically root 2 gm by r. But I feel there is a catch. Read carefully. The radius is doubled, 4 times, but same mass, not mass, mass density. If somebody forgets to read the word density, then tata, bye bye. Psh, psh, gone. Okay, gone. Tata, bye bye. Okay, so what you need to do? What is density? Density is mass by volume. Mass is density into volume. Volume is 4 by 3 pi r cube. Oh, put this here and see what do we get. We will get root 2 g divided by r. Instead of mass, put density into 4 by 3 pi r cube. Why did I put 4 by 3 pi r cube? Because it is a square, circle, hexagon. What is it? Sphere, no? What is the volume of sphere? 4 by 3 pi r cube. That's why I put that. Okay. Now what happens? R square. Now all the other things on one side like 2, g, rho, 4, pi by 3. But r square's root is r. R square's root is r. So this is your escape speed. This is your escape speed, correct? So what did I get? Escape speed is directly proportional to r, because all these people, all these waste fellows, they are constants. They are all what? Constants. Yes or no? They are all constants. Yes or no? So basically velocity is directly proportional to r. The radius is made 4 times. This radius is made 4 times. What will happen to the escape speed? That will also become 4 times. Correct? Correcto? Answer B-O. B for Bahubali. Thank you, Vasu. I love you all, sirs and madams. I will definitely let HSP Sir, Wassim Sir know, and Ambika ma'am also know. Thank you so much, Vasu. Okay, moving on to the next question. Black hole. Oh my God. Oh my God. Black hole, guys. Crazy. Many students will leave the question listening to the word black hole only. Sir, what nonsense. Black hole question. What do they think? We are doctors. We will be on planet Earth. Where black hole and all? Black hole is an object whose gravitational field is so strong even light can't escape it. To what approximate radius should I compress the Earth so that it becomes a black hole? Crazy. Let's try to solve this question. If it has to become a black hole, even light can't escape it. That means the escape speed should become the speed of light. Speed of light is 3 into 10 to the power 8 meters per second. We all know the escape speed formula is root of 2 gm divided by r. Square this. V square will be 2 gm divided by r. So r will be, take r on the top, v below. So v square below, 2 gm remains as it is. Now substitute 2 into 6.6 into 10 to the power minus 11 into mass of the earth, 6 into approximately 6, 5.98 is 6, 6 into 10 to the power 24. This whole thing divided by escape speed. What is escape speed? C. 3 into 10 to the power 8 whole square. This will become 6 2s are 12. So 12 into 6.6 into 10 to the power minus, 24 minus 11, that's 13. Okay. Whole thing divided by 3 square is basically 9 into 10 to the power 16. This will become, now observe this carefully what we can do. 9 goes 3 times, this goes 3 times to 4. This 3, if I divide 6.6 with, so that will give me 2.2 because 22 into 3 is 66. Correct? So what will I get? What will I get? 2.2 into 4 is 8.8. So it will be 8.8 into 13 and 16. So 10 to the power minus 3. But I want only in powers of 10. So here actually I have made some approximations. This was actually 6.67. So actually the answer will be slightly more than 8.8. Answer will be actually slightly more than 8.8. 8.8 I can approximately tell this is very close to 10. Na? Approximately 10 into 10 to the power minus 3. 10 into 10 to the power minus 3 will be 10 to the power minus 2. So hence that should be the closest answer. Thank you, Sultan. Yeah, B for best teacher. Thank you, Subiksha. Oh my God, people are consoling Champa. Is Champa angry? Champa is sad. What happened, Champa? Oh my God. 10 to the power minus 2 meters. That is the correct answer. Everybody, shall we move ahead? Understood these calculations? These calculations, are they tough? No, simple. Just go with the flow. Think of some approximations. Think of some manipulations. Manipulate it, you will get it. Okay? Chalo, moving on to the next one. Kepler's law and satellites. So over here, basically in Kepler's law, main thing is, if you have, let's say for example, the first thing is for satellites. If you have a planet of radius r, okay, this is a planet of radius r, and let's say you have a satellite of mass m which is going around that particular planet. This is that orbit of the satellite, This satellite will have certain speed. That speed is given by root of g, mass of the planet, not of the satellite. Capital M is the mass of the planet. Okay, gm divided by that radius of the orbit. This entire thing, it includes the radius of the planet plus the altitude. So this is small r. So divided by small r. This is very, very important formula, guys. The speed of the satellite moving around in a circular orbit. This is your circular orbit, okay, around a planet. Also, there is a formula for time. Okay, you should know this. Time period will be 2 pi root of, here you will have r cube and at the bottom you have gm. So this is also the formula which is very important for finding the time period of the satellite. Certain very important things which you should know over here is, for a geostationary satellite, the time period is 24 hours or basically 86,400 seconds. In one complete day, it completes one revolution because it moves along with the earth. That is why it is called a geostationary satellite. Okay, very important. Surface satellites. For surface satellites, the thing is that the radius is approximately equal to the radius of the planet. Basically, the altitude is basically small. The altitude is basically small. That is a very, very important approximation which is done. So instead of small r, you can automatically put capital R to get the approximate answer. Cool? Great. Ambika ma'am's class will be after mine. Chemistry class is done after mine, Ambika ma'am's class. Now, this is first thing about satellites. Now talking about Kepler's laws. See, first thing is, if this is the sun and this is a planet which is going around the sun, So let's say this is our planet which is going around the sun. The path taken by the planet, this is the first law, the path taken by the planet is elliptical. It is elliptical or basically circular. In some special cases, it could be also circular. So it is elliptical or it is basically circular. That is the first law of Kepler. This closest point is called perigee. This is, or perihelion, and this point is called as apogee. P close, apogee not close, far away point. So it goes in an elliptical orbit such that the sun is at one of its foci. You will basically, if you have studied maths, then you will understand ellipse has two foci. One focus is here, other focus is here. So this is focus number 1, this is focus number 2. This is the center of that ellipse. So this is the center of that particular ellipse. But focus is something different. It is not the center of the ellipse. So one focus is here, one focus is here. Obviously you can't have two suns, so there is one sun, there is one planet. So the sun will be either at this focus or the other focus. Both are symmetrically placed. This is the first law. Everybody with me? Everybody with me? Okay, very good, very good. All right. Now the next law of Kepler is the law of areas. So if this is the sun, okay, if this is the sun, the planet is going in this particular orbit, then if you see a line which joins the planet and the sun, and you see how that line moves after some time, probably it will go here. This is the area swept. This is the area swept in that particular time. Now let that planet reach here. If you measure or if you draw that line from the planet to the sun, wait for some time, that line will probably come over here, and now calculate this area. Then wait for the planet to maybe come here, just draw that line here and maybe over here after some time, and then calculate that area. Guess what? All the areas will be equal if the times are same. So that is the second law. So the area swept by the planet, area swept by the planet per unit time is constant, is basically constant. It is in fact L by 2m. Now what is this L? What is this L? Come on my dear warriors. This L is nothing but the angular momentum. This is nothing but angular momentum. So if this area swept per unit time is constant, that means L by 2m is constant. Mass of the planet is not changing. So L is constant. So basically angular momentum is actually a constant. It is basically conserved. It is basically conserved. That is why that area swept is the same. Very nice. Now you can also see, because here the area is, the area looks wide but it is the same. Here the area looks thin but it is long like that. So what do you guys suggest? Where is the speed more? Where is the speed less? At this point or at this point? At apogee or at perigee? Where do you think the speed is more? Where do you think the speed is less? Obviously because it is thin, it is moving slowly. So here the speed of the planet is slow, but here in that same time it has to come here to make the same area. So here it is definitely fast. So it is slow, it moves fast, then again slows down. And again it speeds up and again it slows down. So this is how it continues. Is that okay? Now there is one more law, and that is the third law. Let me also put that third law over here maybe. The third law is basically the law of time periods. The law of time periods. So it is basically the time period square is directly proportional to the radius cube. To the radius cube. Very, very important. Actually it is the semi-major axis length cube, but you don't have to worry about it so much. You can just take it as the radius cube for circular orbits. This is for circular orbits. But if it is an elliptical orbit, then it is proportional to the semi-major lengths whole cube. This is for ellipse. If you are wondering what is semi-major, let me show that to you right over here. If this is an ellipse, there is one axis here and there is one axis here. This is called minor axis. This is called major axis. This length which is there from here to here, this is called as the semi-major axis. Semi means half, so major, semi-major because it is big. Minor, major, semi means half. So that is how it works. Is that okay? Everyone? Thank you, Sultan, so much for the love. Okay, great. Very nice. Okay, come on guys, concentrate. Hello butterfly. Yes, thank you Vinita, thank you so much. Okay, shall we do some questions? Here comes the first question on your screen. Meanwhile, let me just message our admin because there is one more class of mine. I think I'll have to shift it by at least 15-20 minutes. Just one second. Come on. What do you think the answer is, guys? T is time. T is time period. T is time period. Time period for it to complete that entire revolution. Okay, let's see if you guys can solve this question. If the time period of a satellite is 24 hours at a height of 6 RE from the surface, then the time period of another satellite at a height of 2.5 RE is how much? If you recollect the formula for satellites, here it was, time period is proportional to root of R raised to 3. So basically just going back over here, if I write the time period formula, it is basically 2 pi root of R cube by GM. So basically time period is directly proportional to root of R raised to 3. Now in the first case, if you observe carefully, the height is 6 RE. That means what will be the radius? Radius of that orbit. The radius of that orbit will be radius of Earth plus that height. So it will be R plus 6R. That means it will be 7R. Agree? It will be 7R in the first case. But in the second scenario, what is that new radius going to be? It will be R plus 2.5R. That means it will be 3.5R. Understood? This is the second case. Now let's do the math. Now let's do the math. Time is proportional to root of R cube. So the first time upon the next time will be root of R2 by R1 whole cube. Now what is R2? R2 is this. That is basically 3.5R. What is R1? R1 is basically 7R. This whole thing's cube. Okay. So what will this become? RR cancels. 3.5 goes with 7 2 times. So this will become 1 by 2 whole cube. Now once you get this, what is 2 cube? 2 cube is 8. So this will be 1 by square root of 8. What can I write 8 as? I can write 8 as 4 into 2. So what will that become? That will become 2 root 2. Root 4 is 2, root 2 remains as it is. So that is your T1 by T2. But the question was, what is the, I think, new time period or something. Yes. So T1 is how much? T1 is how much? 24. T1 is 24. T2 I need to find. So doing the math over here. So T2, okay, just check this out if everything is fine. Okay, yep. So T2 will be basically 24 into 2, 24 into 2 root 2. So 48, I think some mistake has been done. I know what mistake has been done. I'm so sorry, guys. I wrote it as R2 by R1. That's a silly mistake. T1 by T2. So T1 by T2 will be nothing but R1 by R2 whole cube, everything under the root. T1 with R1, T2 with R2. Now let's see what happens. This will become nothing but root of R1 is 7R, R2 is 3.5R. So R1 is 7R, R2 is 3.5R. Okay, this whole thing's cube. So this will become root of RR cancels, 7 goes with 3.5 2 times. So 2 cube. 2 cube is basically 8. Now 8's root, I can just write it as 4 into 2's root. Root 4 is 2, so 2 root 2. So basically what I got was 24 hours, because T1 was 24 hours, by T2 is basically 2 root 2. 2 goes with 24 12 times. So therefore I will get T2. T2 is basically 12 by root 2. Rationalizing this, so 12 root 2 by root 2 into root 2. So this will be 12 by 2 root 2. So that will make it 6 root 2 hours. 6 root 2 hours. Where is it? Option 1. Option 1. Correct. Option 1. Yes, that is the correct answer. See, if you guys made some silly mistake, no, it is not Bahubali, it is AFMC, it is AIMS, guys. Be careful. Okay, be little bit careful. Yep. Cool. Shall we move ahead to the next question? Yes, concentrate. Whether CSK wins or loses does not matter now, 1 week before the exam. Your exam is there. Okay, they will continue, they will earn money, they will get fame, but you know, you have to study. Yep. So moving on to the next one. The kinetic energy of the planet in an elliptical orbit around the sun at position A, B and C is K, KB and KC. AC is the major axis and you are drawing a perpendicular at that point S. Then where is the kinetic energy more, where is the kinetic energy less? Cool. Let's see how many of you can do this. Pandu answered the question first time and it came out to be wrong. That's what happens. It's okay. At least you took the courage. Now we all know that when there is an elliptical orbit and this is the sun, this is the point where it is the fastest. This is the point where it is the slowest. Here somewhere the speed will be basically medium. So basically wherever kinetic energy is more, speed will also be more. So at this point A, B and C, so slowest is C, so C will be the least, A will be the most, B will be in between. So that is option B, of course. Exactly. A will be the highest, fastest, then comes B and then comes C. Exactly. Just based on the second law. These kind of questions have been coming. Isn't your confidence boosted now? That sir, actually what you are showing and solving, these kind of questions actually come in the NEET exam. And that's what is true, guys. See, long time back, you know, maybe in AFMC or maybe in AIMS papers, very difficult questions used to come. Yep, maybe at JEE mains level or even sometimes higher than that. But NEET paper is actually very simple. Okay, it's just speed, accuracy and the knowledge. If you have these three things, that's it. You have aced the subject. Moving on to the next one. Standing waves, organ pipes. Let's move to that part. Okay. Apugi will be not A bacha, Apugi will be C. A will be perigi. Perigi is closer. Perigi is closer. Apugi is far. Far is slow. Close is fast. Okay. So be careful. Okay. So let's start solving and understanding the formulas of organ pipes, standing waves and all of that. So what is a standing wave? First of all, so standing wave is produced by two waves of same energy moving in opposite directions. So very, very important. So how does a standing wave differ from a travelling wave? Example, this is a travelling wave. If I show a wave like this, okay, after some time that same wave would have gone here. So it is moving slightly. I hope you guys can see that. It has moved. It is going slowly ahead. After some more time, maybe it would reach here. So the waves continuously shifts from one place to the other. The energy is slowly moving. That is your basically travelling wave. But for standing wave, the wave only looks little different. So for example, the wave is like this right now. After some time, the wave will be here only, just that the amplitudes, or sorry, the displacements will change. After some more time, you will see the wave will probably become like this. Okay. After some more time, maybe the wave becomes like this. After some more time, maybe the wave becomes like this. Okay, like this. And after some more time, maybe the wave becomes like this. So you can see there are certain points which do not move only, but there are certain points which move a lot. Certain points which do not move. Certain points move not as much as these points and not as less as this point or this point over here. So this is the basic understanding of standing waves, guys. These points over here, what are they called? The ones which do not move. They are called as nodes. What are they called, my dear warriors? They are called as nodes. But this, they are called antinodes, which have the maximum displacement. What do they have? Maximum displacement. And what is Each one of these called, what is, let's say for example, this one called, what is this particular part or this part, each one of these, what is each one of this called? They are called as loops, loops or lobes, loops or lobes, L-O-B-E-S, exactly. Everybody with me? Great. Now, whenever you have a standing wave, all these things are very, very important. If you take one lobe, okay, which goes like this, then becomes like this, then becomes like this, then becomes like this, then goes here, then goes here, then goes here, again then comes here. So there is a node here and there is another node here. Remember one thing, the size of a lobe is exactly half a wavelength. If this is one complete wavelength, this distance is always lambda by 2. What is it? Lambda by 2. Keep this in mind. Very, very important. Okay. So there is no crest or trough. Here there is crest and trough. Here the crest comes, goes, then becomes trough. Then again crest comes and goes and again becomes trough. But it is at the same place. Here the crest is shifting. Here the trough is shifting. Here the crest is always at the same place. The trough is also at the same place. Understand? Okay. So that is a big difference between this one and this one. Everybody with me? Cool? Clearo? Okay. Now the last thing is over here is the equation of this standing wave. What is the equation? Just like you have wave equation. What is the wave equation? Try to recollect. The wave equation looked like this. Y is equal to A sine kx plus minus omega t. Yes, I hope you remember. Y is equal to A sine kx plus minus omega t. What was A? Amplitude. What was k? Angular wave number. What was omega? Angular frequency. That is what the wave equation was. But for standing wave, the equation is like this. It is 2a into sine kx into cos or sine, whatever you want to use, omega t. Now please remember one important thing. Here a is the amplitude of any one of those waves. Remember, you need two waves going in opposite direction to create a standing wave. You need two waves to create a standing wave. So A is the amplitude of any one wave, but when I say what is 2A? What is this 2A? This 2A is basically this one over here. This total final amplitude 2A is A plus A, total amplitude. So be careful about this. This is 2A. That is the amplitude of the standing wave. A is the amplitude of one of the waves which produces that standing wave. Complete difference. Okay? Complete difference. Great. I hope this is very, very clear. K is angular wave number, omega is angular frequency. These are standard parameters. You should all know omega is 2 pi f. And what is K, guys? K is nothing but 2 pi by lambda. 2 pi by lambda. Clear? Now, some of you are also asking, sir, when do you use plus, when do you use minus over here? If it is plus, if it is plus, then it is going in the negative x direction. If it is minus, then it is going in the positive x direction. So it's exactly opposite. So the signs over here are exactly opposite to the direction. If it's plus, it's going in the negative direction. If it's minus, it's going in the positive direction. Is that clear? Everyone with me on this? Okay. I think when we'll move to the next part of this, which is standing waves on string and in organ pipes. So remember one simple thing. Whenever you want to produce a standing wave, you can produce it on a string by creating waves, oscillate it, the waves go back and forth and you have waves interfering. There is standing wave produced. Or you can take a pipe, you can say something, or you can take a tuning fork, hit on somebody's head, and you can see the waves will go back and forth, and you will see standing waves in pipes also. So that is sound which is longitudinal, but on a string that is transverse. Yep. So on string, what is it? Transverse. In pipes, what is it? Longitudinal, which is sound waves. I hope this is clear. Now, whenever you have a string, okay, which is basically fixed at one end. There is a string which is basically fixed at one end, or you have a pipe which is completely closed. This is basically closed. Then at that particular point, what you get is always a node of that particular standing wave. What do you get? You basically get the node of that standing wave. Remember that. So there will be a standing wave produced, but you will have a node of that particular standing wave. Very, very important. Similarly, if you have something like a free end, the string can move freely at that end, then what you get, is basically a antinode. So this is an open pipe, or this is basically free end. What you get is maximum amplitude. So antinode is what you will get over here. So this is probably the best way to show it. Antinode. Is this point clear, everyone? Fixed, closed node, free, open, antinode. Now there are three permutations, combinations that you can probably get. First is, observe, you take a string, fix it at both the sides. It's as good as taking a pipe, closing it on this side and closing it on this side. Both ends closed or both ends fixed. So this is fixed here, this is fixed here, this is closed here, this is closed here. This is the first possibility. The second possibility is you take a string which is fixed on one side, but it is free on the other side. So it is fixed here, it is free over here. It's as good as saying there is a closed pipe on one side and it is open on the other side. The third possibility is you have free string. So this is free, this is also free, or basically this is open to move. So in case of pipes, both sides are open. This is also open, this is also open. These are the only three possibilities. Agree or disagree? Agree or disagree, my dear warriors? Come on, think and tell me. These are the only three possibilities. If you take a string or a pipe, both sides fixed, both sides open, or one fixed, one open. Yeah, like a flute. So organ pipe is like flute, trumpet, harmonica, all these things. But string instruments like guitar, sitar, tambola, right? So all these are string based instruments which produce sound. So the science of music starts from here actually. Everyone? Cool? Okay. Now these strings can produce different types of standing waves. So I can show you certain possibilities, like one possibility is this. One possibility is this. Second possibility is this. Third possibility is this. Always notice the ends have nodes. In that same length, the wavelength is changing, but the nodes are there always at the ends. In this case, the possibilities are like this. This is the first possibility. Then the next possibility is like this. Or maybe like this. Look at this. So these are the possibilities in fixed free or open closed end. In free end, both antinodes should be there. So maybe this, or maybe this, or maybe this. All these are possibilities. Everybody agrees? Everybody is able to see that? Very good. Now understand one more thing, the wavelengths and the frequencies will change here, different frequencies. So the formula for the frequency in the first case and the last case is actually same. The formula for the frequency of the wave which is going back and forth is nothing but NV by 2L. What is this N? Any integer. What is this V? Speed of the sound. or that wave which is going on to that string. So NV by 2L is the formula. Whereas here also the formula remains the same, there is no change. You will see that frequency is N times V divided by 2L. N times V, N is any number, any integer. Only problem happens in between. Here the formula becomes F is equal to odd number V by 4L. So 4 comes and odd number comes. 2n plus 1 or 2n minus 1, whatever you want to do. Yep, everybody with me on this? Clear? Understood? Okay. Now the first frequency which is there, this least frequency which is there, here the value of n is 1. This is basically fundamental. What is this? This is basically fundamental frequency. The fundamental frequency is also known as the first harmonic. What is it called? The first harmonic. Fundamental is also called as the least frequency, is also the first harmonic. Everybody should know this. Now, how do these harmonics and overtones work? Let me give you by a simple example. After this, you will never face any difficulty. Observe. Imagine I have 10 Hertz frequency, then I have 20 Hertz frequency, then I have let's say 30 Hertz frequency, then I have let's say 40 Hertz frequency. So harmonic wise, the least frequency is always called as the first harmonic. First harmonic. The next frequency, what you will do? See, 20 is 2 times of 10. 20 is 2 times of 10. Agree? So that means this will be called second harmonic. How many times of the first harmonic are you? Harmony. Harmonic means multiple. Multiple. This is 3 times of 10. So that's why third harmonic. Third harmonic. Similarly, this is your fourth harmonic. Fourth harmonic. Because this is 4 times your first harmonic. This is 3 times your first harmonic. This is 2 times your first harmonic. Is that clear? Is that clear? Very nice. Now, the lowest frequency, which is also the first harmonic, is also called as your fundamental. Fundamental frequency. What is it called? Fundamental frequency. Now, the next frequency, you can call it as the harmonic, second harmonic, but in overtones language nomenclature, that is called as the first overtone. What is it called? First overtone. This is called second overtone. That's the next frequency. This is called third overtone. This is how the nomenclature works. First, second, third, fourth, etc. If you want one more example, I will give it to you. After this, you will never face any difficulty. Imagine 10 Hertz, 20, 50 and then 70. Okay, just imagine these numbers. 20 Hertz, then 10 Hertz, 20 Hertz, 50 Hertz and then 70 Hertz. Which harmonic is the first number? This is always the first harmonic. This is 2 times of 10. So this will be second harmonic. 50 is 5 times of 10. So this will be fifth harmonic. 70 is 7 times of 10. So it will be seventh harmonic. Agree? Not all the harmonics are there. Only few harmonics are there. Now, if I ask you, what about overtones? First thing, this will be the fundamental. This will be the fundamental, yes or no? This will be the fundamental. Now, this is the first frequency you get after fundamental. So, numbering wise, this will be just called first overtone. The next frequency is just called second overtone. Here you don't check multiples. Here you don't check multiples, you just go sequentially 1, 2, 3, 4 like that. So, this is the next frequency. This is the third frequency after fundamental. So, third overtone. Is that now clear? Is that now clear? Everyone? Everyone? Clear? So, same thing if you apply over here. Here you will notice n. N can be any number. 1, 2, 3, 4, 5, 6. All the harmonics. 1 times V by 2L, 2 times V by 2L, 3 times V by 2L, 4 times, 5 times. All the harmonics will be present. Correct? Oh, so over here, all harmonics are present. All harmonics are present. Here, only odd harmonics are present. Odd harmonics are present because it is odd times. 1 times, 3 times, 5 times, 7 times. Is that clear? Oh? Very good. Very good. No, this is not fourth overtone. Overtone is over the fundamental. This is the first frequency over fundamental. This is 2 frequencies over fundamental. This is 3 frequencies over fundamental. So, fourth harmonic is basically 4 times first. This is multiplication. This is not multiplication. This is serial number 1, 2, 3, 4, but after fundamental. Clear? After this you will not face difficulties. Let's start solving some questions. Solve this question. A string is fixed at both ends. It's vibrating in second harmonic. Amplitude is 2 millimeters. What is the amplitude of the particle at a distance of L by 8? Distance of L by 8. Okay. So, at this distance, what is the amplitude of the particle? Okay. First things first, what is the best way to do this? We know the equation of standing wave is y is equal to 2a sin kx cos omega t. In this entire equation, this is a function of time, but this one is basically your amplitude. This one is the amplitude of any point on that wave. It is the amplitude of any point on that particular wave. That is very, very important. So now this is how you are going to always analyze this equation. Not this 2a is the maximum amplitude. Remember, 2a is the maximum amplitude, but amplitude of any place is this whole function 2a sin kx. So let's use that. Let's use that. So the amplitude of that particular point is 2a into sine of kx. But what is the value of 2a? I'll just think about it. Instead of k, I'll put it as 2 pi by lambda into x. Now, let's write down each one of them, whatever the values I'm going to get. First things first, the amplitude of antinode is 2 millimeters. So, 2a is 2 millimeters. That means, how much is a? That is 1 millimeter. Everybody agrees? So, a is basically 1 millimeter or 2a is 2 millimeters. It's clearly mentioned. Amplitude of antinode is 2 millimeters. So, instead of 2a, can I just put 2 millimeters over here? Now, what do I put inside? 2 pi is there. What is the value of lambda? What is the value of x? X is basically L by 8. It is clearly mentioned at a distance of L by 8. So, I'll put L by 8 over here. For lambda, what do I put? For that, observe carefully. This is entire wavelength. So, can't I say lambda is also equal to L? Lambda is also equal to the length L. So, instead of lambda, just put L. L cancels. 2 cancels with 8 4 times. Pi by 4 means 45 degrees. What is 45 degrees sine? What is 45 degrees sine? It is 1 by root 2. It is basically 1 by root 2. That's it, guys. So, 2 and root 2 cancels. It will be root 2 millimeters. That is the answer. Root 2 millimeters. Yes, it's not 2 root 2. It is root 2 millimeters. See this carefully. Crazy. Alam understood? No, Surya, it is not 1. It is option number 3. Option number 3. These kind of questions do come in the NEET examination. You should be very, very careful. You should know each and every aspect about the problem, what we have done, why we took 2a, why we took a, why we took lambda as L. I have explained each and every step of the problem. You can't so easily eliminate the options, bacha, over here. Another question coming up on your screen. Let's see if you guys can do this. The length of a string in a musical instrument is 90 centimeters. It has fundamental frequency of 120. Where should you press it to produce a fundamental frequency of 180? Okay. See, guys, in this question, the length of the string is this much. So, imagine it is producing fundamental frequency like this. I can use this formula, F is equal to NV by 2L. That frequency is 120 Hertz. Because it is fundamental, N value will be 1. Velocity, I do not know. length value, is it given? Length value, is it given? Yes, it is 90 centimeters. From this, I get the value of velocity as 120 into 2 into 90, which is 120 into 180. I'll just leave it as it is. That's the value of the velocity. I think I will need it later on. Now, you want to change it to a new instrument of basically 180 Hertz frequency. So, again if I use this same formula, but this time I'll put the frequency as 180 Hertz, n value fundamental, because it is clearly mentioned it is fundamental, into V divided by 2 times, I do not know what the length should be. So, I'll just put it as L. Here, I can put the value of V as 120 multiplied by 180. 120 multiplied by 180, here I will get 2 into L, here I have 180. 180 cancels, 2 cancels with 120 60 times. So, L goes on the top. So, L will be basically 60 centimeters. So, 60 centimeters is option 2. 60 centimeters is option 2. Crazy. That is the correct answer. That is the correct answer. Very good, guys. Very good. Excellent. If you guys got this as 60 centimeters, very good, Nishkarsh. Excellente. Excellente. No, it is not anything else. Yes, very good, Aditya Bhuvan. Yes, Akshita. Very good. Excellente. Moving on to the last few concepts. Moving on, guys, and that is Doppler effect, beats, and then after that we'll just have speed of sound and all of that. Just 1 second. Okay, great. Guys, tired? Break? Udaysri saying break. What nonsense, no ways. Come on guys, concentrate. You have to sit in the NEET examination for 3 hours 20 minutes, okay? So, let's continue. Beats and Doppler effect. First, let's talk about beat and then I'll go to Doppler effect. Simple. What is beats? Beats is basically, alternating loud and faint sound which is produced by interference of two similar sounds, meaning if you take sound of frequency F1 and you take sound of frequency F2, F1 and F2 are very close to each other. F1 and F2 like 400, 410, 300 Hertz, 305 Hertz, 700 Hertz, 712 Hertz, these kind of frequencies. So, then the difference of the frequency gives you something called as the beat frequency. So, what is the meaning of this beat frequency? Let me explain you in simple words. Imagine you hear loud sound, then you again hear faint sound and again hear loud sound because of two sounds interfering with each other of similar frequencies. Suddenly the sound becomes more, suddenly the sound becomes less, suddenly the sound becomes more, suddenly the sound becomes less. So, that happens because of this phenomena called beats when two similar sounds are together, loud and again after some time faint. Then realize this particular thing from one loud to the next loud or from one faint to the next faint, that is called as the beat period. What is it called? This is called as the beats period, from one thing to the next thing, similar thing. Now, what is this beat frequency? This beat frequency is nothing but 1 by that beat period. This is 1 by that beat period. So, if there is one loud sound and the next loud sound is after 1 second, 1 second you get the next loud sound. So the beat frequency is 1 Hertz. That means every 1 second you get a repetition of that loud faint, noises. Is that clear? Yes, Maulvi. I'll be coming to the other channel. Just give me some time. I have shifted. I will be starting it at 8:45. 8:45. Yep. Something like the ambulance sound. Yep. Great. So this is the first important formula which you should know. Very good. Now the next important thing. Guys, very, very crucial, is that, okay, Doppler effect. Now what is this Doppler effect? In Doppler effect, because of the relative motion between the source and the listener, the apparent frequency heard is different. Very, very important. The apparent frequency heard is different. Let me show this to you by drawing the figures, and then I will explain you how to use the formula and all of that. Imagine you have the source. Okay, and let's say it is moving with a speed of Vs, and somewhere here you have the listener, or sometimes even called as the detector, whatever you want to call it, okay, and that detector, the person who is trying to listen, is moving with speed Vd. Imagine the original source is generating a sound of frequency f0. The listener will hear some other frequency, I will call it f1, f prime, f apparent, whatever you want to call it. This f1 is basically original frequency. In the numerator and denominator, first put speed of sound. Always put source below, put detector on the top. Velocity of the detector on the top, velocity of the source below. You can go alphabetically also. A, B, C, D, E, F, G. D comes first, S comes later on. Then put plus or minus. The signs are decided based on how they are moving with respect to each other. The logic is as simple as this. If they are coming closer, then what you should do is numerator should be increased, denominator should be decreased. As simple as that. Basically, once they come closer, the apparent frequency increases. So try to increase the numerator, try to decrease the denominator. If whichever part is coming closer, source is going close, source is moving towards the detector, what will you do? Source, where is source? Below, right? So what will you do? You will try to reduce the denominator. So what sign will you use? Minus. Minus in the bottom. If the listener or the detector is coming towards this guy, then what will you do? You will increase the numerator. So to increase, you will make it plus. Is that clear? Guys, concentrate on the class. I can see a lot of you are deviated. If you guys talk random things, I'll have to block all of you guys. Yep. Come on guys, concentrate on the class. Stop asking each other your age, hostel, this, that, whatever, what are you guys doing? I'll have to block. Okay, I'll be blocking all of you in case you spam. Yes, concentrate on the class. This is not Tinder. This is not your dating platform. Okay? And if you feel like dating, there are apps I can suggest you, or go to matrimony sites. This is not your Tinder platform. Okay? Concentrate. Yep. So this is one thing. Second thing is, if you see any one of them going far, then the apparent frequency will reduce. How do you reduce? Making the numerator smaller or make the denominator larger. That's what you need to do. I hope this is clear. Exact opposite. If one of them goes far away, make the numerator small or make the denominator big. That's the simplest logic that you can think of. Let's do some questions first. In a guitar, two strings are there. Same material, slightly out of tune, produce beats of frequency 6 Hz. If tension of B is decreased, then the beat frequency increases to 7 Hz. A's frequency is 530. What is the original frequency of B? Okay, let's try to understand. First of all, the frequency for A is clearly mentioned to be how much? 530 Hz. The problem is with B. First time when B is sounded with A, the beat frequency is 6 Hz. If beat frequency is 6 Hz, that means the difference of their frequencies is 6 Hz. So 530 minus what will give you 6 Hz, or what minus 530 will give you 6 Hz? There are two possibilities. B can be either 524 Hz, or B can be either 536 Hz. Both of them will give you a difference of 6, because there is always a mod. I don't know who is bigger, who is smaller as of now. I just know that the difference is still going to be 6. Okay. Now which answer will you choose, or which answer will you block? Obviously it can't be 523, it can't be 537. Oh, but this option is also there, this option is also there. See, option 1 and 2, it has to be between 1 and 2. Now what do we do next? Read the next piece of information. When tension is reduced, then beat frequency increases. How is tension related to frequency? Remember standing waves on a string? In that case, frequency is NV by 2L. What is the value of V, guys? It is root of tension by the mass per unit length. That is the formula. So now think, if the tension is decreased, then what will happen? Numerator will decrease, even the frequency will reduce. Okay, now think logically. If the beat frequency now becomes 7 Hz, so now the value becomes 7 Hz, so the difference should be 7. So 530 minus 7 will be 523. 530 plus 7 will be 537. If 524 becomes 523, the frequency will reduce. If 536 becomes 537, the frequency will increase. Actually what is happening? The frequency should reduce, right? Not increase. So out of B1 and B2, which is the correct assumption? These were just assumptions. We are assuming these two. Where do you think the frequency reduced in this case? Hence, I will choose this one. Hence, the correct answer will be 524 Hz. 524 Hz. Is that clear? No problem, Alan. Yep. Is that clear? Everyone with me? Nagendra, I'll have to block you, bacha. Great. Very good. Very nice. Moving on to the next question, and that is on Doppler effect. So usually you will get these kind of questions. This is a standard question, so I am doing it for you. So you will be given, like, there is a car or something. Okay, that car is sounding some horn of some frequency. The car is going with some speed. There is a wall over here. The sound gets reflected and the driver hears it, or something like that. Whenever you get questions like this, what you should do is immediately convert it into an equivalent question like this. Keep the car, let the sound be generated at F0, let the car move at speed V, forget there is a wall, just think there is another car from the other side coming this way exactly with the same speed. Just like a mirror. Mirror the car, just like a mirror image. This is like a mirror image of the car. Now this guy will become like the source. This guy will become like the source. This guy will become like the detector. The sound is going like this. So this guy will become like the detector. Now solve the problem normally. the apparent frequency will be the original frequency, speed of sound, velocity of detector, velocity of source. Now think carefully which sign will come where. Source is going closer. Close means frequency should increase. Closer means it should be increasing. Correct? Yes or no? Okay, very good. It should increase. So what should happen to the denominator? It should become smaller. Once the denominator becomes smaller, the ratio becomes large. What should happen to the numerator? Detector is coming close. Detector coming close means frequency will increase. Frequency will increase means numerator will increase. So hence this will become plus V. This is how you solve the problem. Very nice. So plus on the top, minus below. Plus on the top, minus below. Clear? Understood how to solve these Doppler level questions? No problem, Jennifer, you will understand it now after these mistakes and you will not make the mistake again. So the last topic, guys, coming up on your screen. Wave speed. Yep. Let's do this. Wave speed on a string and sound. Alright. So if you have a string which is under tension, and you generate a wave, you will see that it will move with the speed v. This v is given by root of t by mu, where t is tension, and mu is mass per unit length. Sometimes mass per unit length is not directly given. So in that case, what you will do is just take density and multiply it with the area of cross section. So what is rho? Rho is nothing but your normal density, if that is given to you, and A is nothing but cross sectional area. That is what it is. So you can find mu using that. Kg per meter is the unit of mass per unit length. Is that okay, guys? This is the speed of a wave on a string. This is for transverse wave on a string. But longitudinal waves basically sound. Let's talk about that also. Longitudinal, basically the example of sound. Now sound can travel through solids, can travel through liquids, can travel through gas also. All three of them. Okay. So guys, come on, focus. Praveen Bantu, you will be also blocked, bacha log. Don't deviate from the topic. Don't spam the chat. You will get blocked. Make sure you're concentrating on the class. Yes. So the longitudinal waves, which is basically the sound waves. Okay, Ambika ma'am wants to come in the class. Obviously, she has come here to disturb.
Obviously.
Very good.
So
Let me remove the.
not break that trend now that I disturb everyone.
Yeah.
Isn't it? How are you, everyone? How are you? How's your session going? I can see the energy that Shreyas sir is putting, isn't it? Huh? So I was just checking sir's session and I know he's so energetic and the way he's teaching the concepts, na sir, seriously, honestly, jokes apart, today I was listening to you and I was like, okay, physics is not that difficult.
Which part were you listening, ma'am?
The earlier question where you were like, pause students for reverting plus and you were like, when it will increase, something increase and decrease. So
correct.
I was listening to that. So first of all, tell me everyone, how are you doing? Tell me. Tell me.
Oh, look at that. Fire is only there for Ambika ma'am. Huh? When all this time, Shreyas sir was here, no fire. ऐसे एकदम normal smiles are okay.
So actually I was just waiting that I should not break that trend that I used to disturb other teachers in their classes. Trust me, you people are going to miss that. Literally.
I agree.
Soon we will move to different cities and then we will take our sessions from our home. So at that time, you people are going to miss that. Literally.
Ma'am, you know what? Within 1 week, just imagine their NEET exam will be over. Exactly 1 week from now.
Huh?
That's it. After that, these kids will not even see us, I think.
They will not, even they should not, because we really want that you people should go to very, very good colleges. But sir, we'll keep guiding them, no?
Yeah.
We'll keep guiding. You
Guys,
have
the
to
journey will
decide,
not be
na,
over.
You know the reason.
Yeah. Oh, yeah, I know. Guys, what do you think the reason is? So, guys, it will be crazy. Please don't forget us, because, you know, the things are going to go on even after your NEET exam. Which college to choose, what to
Yes.
do in life.
So
we
we'll
are there.
keep
Farewell
guiding
party
you.
also. Yeah, we'll have farewell party also. We'll make Wassim Sir dance, we'll make Ambika ma'am dance, HSP Sir dance, and it will be good if you guys also get some crazy good ranks. You come over here, even if you don't get ranks, it's okay. Just, sir, you know what, I didn't clear NEET, but I want to just clear my mind. We want to just dance with you, sir. Okay, just come off, and we'll have a nice grand party with all of you. It will be crazy. So, we would love to do that.
And one more thing.
Already saying miss you. Are
You should not. We still have
are here,
time.
we are here.
Actually, why am I here? Let me tell you first thing. The first thing is ki I am not keeping well. Although I never look, you know,
Oh.
I never look
Really?
like
You're
that.
not well?
Seriously, Anna, and I never look like that I'm not well at all, because I always remain like that only. Matlab, if I will be on my deathbed, na, then at that time I might look, yo, she's
Oh,
not well.
like, yeah, okay.
So it's just that I'm literally not feeling well, having headache and all. So after Shreyas sir, I will not be able to take the session. I'm really very sorry for that. I apologize for that. But tomorrow at 11, I'll take the session. I was just checking out my Telegram. Many students were mentioning it that, ma'am, please do not take the entire marathon on plant physiology. Ma'am, do not take. Guys, we have planned our sessions accordingly. We know you people are running out of time. We literally know that. In Shreyas sir's session also, tomorrow, he's going to teach you the basic things of that topic, the most repeated things. Even in plant physiology, I'll do the same thing. And I'll come up with the same session on some another day. Either it will be a recorded one or it will be a live one, but surely I will. Done.
Okay,
So
perfect.
that's why I came here to inform
No
them.
problem.
And I'm literally sorry for that. But yes, I have shared one video on how to break the tie and about that strategy to attempt the NEET paper. Do check it out. And yes, sir, tell them about the admit card wala.
Yes, the admit card will come out very soon. See, please don't get fooled by seeing things like, sir, admit card is out, this is out. No, when the things will be out, we will tell you on this channel. We will not lie to you, will not just make, you know, some titles for, you know, where you get misleaded. No, we are going to tell you as soon as the admit card is out. So make sure you stay subscribed on the channel and make sure you hit the like button, or else you will not get the video suggestion. So please, for Ambika ma'am at least, you should like and also subscribe.
For us, for our team.
For our
people
team,
should
actually.
like.
Yes.
So sorry, we are very sorry. Matlab, I planned it ki I'll teach you 10 topics, and that 10 topics I'll definitely cover. You know, now whatever we have promised when it comes to human physiology, I covered the entire human physiology. We are going to do the same thing. So after sir, I will not take the session, but all I can say is now focus on physics. You people have already revised the chemistry, and then for biology, save your day. Tomorrow at 11 a.m. we are going to meet, and I will teach you the most important plant physiology topics, and you know that which topics are very, very, very important. So we are going to cater that only, and I'll make sure that I'll finish that session, and you know, I'm trying to finish that session in 3 hours. Either in
That's
3
very
or 4
good.
hours.
That's
in
very
3 or
good.
4 hours, I'm going
That's
to finish
very
that.
good.
Then Shreyas sir will come, and sir, please tell about your session.
I think
Ma'am, it
tomorrow,
is important
tomorrow I'm
you're
coming at
confused.
4 o'clock if I'm not wrong.
Yeah,
Tomorrow I'm coming at 4 o'clock for wave and ray optics, most important subtopics out of those 60 topics only. Concentration only on 60 topics, 60 topics, 60 topics. That's it. Because our aim is to get you at least 140, 150 plus.
Exactly.
Yes. All right.
And stay tuned. Shreyas sir is having a plan. He will share the most repeated topics with you, right? And by doing that topics only, you will be able to score very, very, very
Yeah,
good.
I'll make a separate video because some students were like,
Yes.
sir, we want at least 90 to 100 marks. Guys, how many of you are in that range?
That
Like,
you are
just want
hoping 100
90
marks.
to 50, 100 marks in physics I'm talking about. How many of you are there like that, guys? Raise your hand or leave a comment. Raise your hand quickly. How many of you just, somehow, sir, Just give us 90 to 100 marks. That's enough. Baki, it's okay. I will score in biology or chemistry. Somehow I will get. If you want that.
Actually, na, we were analyzing some things. We were analyzing our comments. We were checking our telegram. So we found that many medical students, they are not able to cover the entire physics syllabus, right? They just want, you know, few topics only. They just want 100 marks. Some students, they just want 100 marks because their biology and chemistry is good. Some students, they are hoping for 130 plus. So Shreyas Sir is having a plan. He's going to share the list of the topics by which you will be able to score 100 marks in the physics. But yes, you have to complete that topics properly. Okay, so this is what we are planning, guys. So please tell me, are you guys interested in such type of video? Only then he's going to work hard. If you people are interested, if you people want that, only then he's going to work hard. So tell me, everyone, tell me.
Yes,
Oh,
looks like
sir,
it
I
is.
like your mic.
Yeah.
I need your mic.
Okay.
And yes, Shreyas Sir is teaching you, so I think the chat rate should be high for him, right? Chat rate should be high for him.
Very good. So let's complete this topic, guys, and Ambika ma'am will see you again tomorrow at 11 o'clock for the remaining topics. All right. So let's continue. See you, ma'am.
You please
okay, you
continue.
take care, ma'am.
So guys, subscribe. We really need your love. We really need your support.
Thank you so much. Thank you. Take care. All right. Okay. So let's continue with the last part of this particular session, and that is longitudinal waves. I think we were talking about the wave speed and all of that. Just one second. Let me just. Okay. So first is sound can travel through all the three different mediums: solids, liquids, as well as gaseous. Solids, liquids, as well as gaseous. So the speed of sound in a solid is given by root of Young's modulus by density. This is your Young's modulus. This is your Young's modulus. This is nothing but your density. What is this? This is nothing but your density. Just one second, guys. Yeah, density. That is the first formula which you should all know. The next formula is for speed of sound in liquids. Speed of sound in liquids is given by root of bulk modulus by density. So this is nothing but your bulk modulus. In the chapter of elasticity, right, you would have learned this. But when we talk about gases, speed of sound in gas, then it is root of gamma P by rho. What is gamma? Gamma is the ratio, Poisson's ratio, Cp by Cv. P is nothing but your pressure. P is nothing but your pressure. So if you want, you can also write the speed of the sound in gas as gamma RT divided by the molecular weight. That is also fine. R is gas constant, T is Kelvin, temperature in Kelvin, M is your molecular weight. Alright, so that is how you can write it as well. So these are the formulas which will come, guys. Very common. Everyone with me? Shall we go ahead do some questions? Here comes the first question. If the initial tension on a stretch string is doubled, then the ratio of initial speed and the final speed on that string will be how much? Okay. Speed of sound on a string. Speed of sound on a string is given by root of tension by mu. So V is directly proportional to the root of tension. Speed will change if the tension is changed. So V1 by V2 will be root of T1 by T2. What is T1? What is T2? Look at that. The tension is doubled. So T1, if it is T, T2 is 2T, T cancels. So it will become 1 by root 2. So that is the value of V1 by V2. So 1 by root 2 is there as option number 4. No, it is not C, bacha log. It is option D, option 4. Yep. How many of you got this? Some of you made the mistake. Very good, Isha. Very good, Akid. Awesomeness. So see, if you make a mistake, silly mistake, you will write root 2 by 1. So be little careful. It was not final by initial, it is initial by final. Very nice. Moving on to one more question coming up on your screen. Imagine the question says, what is the ratio of RMS speed of the molecules of the molecules of an ideal gas to the speed of sound in it, to the speed of sound in it. Let's try to answer this particular question. Ratio of the RMS speed to the speed of sound. What is the formula for RMS speed? RMS velocity is root of 3RT divided by m. That is the formula for RMS speed. What is the speed of sound? What is the speed of sound in gas? What is the speed of sound in gas? It is root of gamma RT divided by m. Now if you divide both of them, VRMS divided by V, speed of the sound in that particular gas, what and all numbers will get cancelled? R, T, T, M, M. So what will be left? Root 3 on the top and root gamma over here. So it will be basically 3 by gamma's root. That is the answer. These kind of questions can also come. These kind of questions can also come. Be careful. B, yes. This is very interesting question because two chapters are combined. Kinetic theory of gases and speed of sound on gas. Two chapters are combined together. Okay. So these kind of questions can also come. Let's look at one last question. If N1, N2, N3 are the fundamental frequencies of 3 lengths or 3 segments of a string which is divided, what is the original fundamental frequency given by? Very nice question, guys. This is beautiful question. Imagine you have a string of length L. Then what will be the frequency fundamental? It will be 1 times V by 2 into L, right? That will be the fundamental frequency. That will be the fundamental frequency of that big string. Now you divide it into 3 parts. One part length L1, second part length L2, third part length L3. Each one of them will have individual fundamental frequencies, like N1 will be V by 2 L1, N2 will be V by 2 L2, N3 will be V by 2 L3. Achha. Is L1, L2, L3 and L related? Yes, it is. We all know that the total length is L1 plus L2 plus L3. Achha, now I know what to do. Guys, from this formula, can you find the length? Length will be V by 2N. 2 is here, V is here only. Take L on the top, take N below. V by 2N. Same way over here also. What is L1? It is V by 2 N1. What is L2? It is V by 2 N2. What is L3? It is V by 2 N3. Correct? Yes or no? So now just substitute all of them over here and see what do you get. It will be V by 2N is equal to V by 2 N1 plus V by 2 N2 plus V by 2 N3. What will get cancelled? V, 2, 2, 2, 2. So what is left? Only thing left is 1 by N is 1 by N1 plus 1 by N2 plus 1 by N3. That is what is left. That is what is left. Very good. So where is such an option? Option 1, I guess. Option 1, I guess. That is it. That is it. Very good. Excellent. Very nice. Very nice. Awesome, awesome, awesome. I hope this is clear. Very good. Guys, don't spam. Yeah, concentrate on the class. All right. So that's it from today's session actually. So we have completed 10 important topics from physics for your NEET examination. If you have mastered these 10 topics today, at least I am saying, at least you will get 40 to 50 marks minimum in the upcoming NEET examination. 40 marks at least you will get, 50 marks if things go really well. So that is the contribution from just these 10 topics that you have studied out of the top 60 topics. And if you have attended my previous classes, you would have studied by now more than 30-35 topics. Yes or no? How many of you have been attending all the marathon sessions? Do let me know in the comment section below and smash the like button and also hit the subscribe button for your Shreyas sir, for your team Avengers, and make sure that you comment in the chat box how the session was, what part of the session you enjoyed the most, or what would you want next. Okay, so let us know whatever. Maybe you are just sad. You can just say, sir, I'm sad. It's okay. You can just say that. Sir, I'm very happy. Just say, I'm sir very happy. Sir, I'm very nervous. So it's okay. Just let us know. I want to know your mood, and by sharing, probably you are letting your feelings out, and probably that will calm your mind just 1 week before the exam. Shreyas sir is going to be with you. Your captain, Shreyas, signing off. Hasta la vista. Take care. Good night. Have a lovely weekend. And see you tomorrow for the next class at 4 o'clock on ray and wave optics. Bye bye. Hasta la vista.